Okay. Wow, we made it. Good morning, good afternoon, Danilo and Hajar.
Hello, Hajar. Ciao, Pete.
Hi, Pete. Hello.
Great. So, Danilo, your audio level is a little high, slightly high, but that's okay. You have a good voice. But yeah, I guess we have a good crowd today for our third. I was going to say third annual. I guess it's like biannual Generative Edge AI forum, right? And so I'm going to hand it off to you folks to do some stuff, and then I'm going to talk to Samir after that. But yeah, this has been great. I think this is the third one we've done. We started this in March of 2024, and it's been sort of a lifetime of AI since then, especially in the generative space. So yeah, any kind of expectations for today in terms of what you're going to hear?
Certainly great expectations, but certainly will be fulfilled because we have really top people, industry leaders, and I'm sure we will have a great fun and we will learn a lot.
I think we're at a unique moment in time, one where the power of generative AI is no longer confined to research labs or the cloud. So now, making its way to the edge and closer to our devices, our cities, our lives, our homes. And with that shift, there is an interesting question. What kind of impact can and should we create when intelligence lives everywhere?
Right. Yes. No, that is a good point. It has now been sort of unshackled from the cloud. And I was at Computex actually last week and had an opportunity to spend a lot of time with our partners there. We had a partner pavilion, had partners demonstrating all around the event, and such a energy there. Now, of course, that's Computex is really sort of the hardware supply chain for AI show, I would say. So there's a lot of data center stuff and a lot of cables and handles. And interestingly, I thought the big winner at the show were people in the cooling system business. So liquid cooled, oil immersed fans. I mean, it was everywhere. And I thought, isn't that interesting that we have now created an ecosystem where it requires so much cooling? You know, what if we could run AI models without all the cooling? I mean, it might not be good for all the folks in the cooling business, but I think we're getting there. I think we're getting there to run AI in lower power, lower cost, lower heat chips for most scenarios. And I think we're going to talk about that today. So that's exciting. So, okay, well, why don't we bring up the agenda and things, and Danilo, if you want to kind of go through that and give us kind of the lay of the land, that'll be awesome.
Thanks, Peter. Hope now the mic volume is a little bit
Excellent.
better. Fantastic. Thank you. So first of all, I'm really excited and very honored to be here today with Hajar, Professor Moussanif, and we together chaired the working group up to what we are going to experience today. So the journey about generative AI impacting the edge. And we will hear today many people and experts which really substantiate that this title, which is exciting, but really we are convinced that we will have a lot of examples which will be convincing and will prove that the technology is around the corner and will happen sooner than really me personally thought. And this year will be a great year for the generative Edge AI. So thanks a lot, Hajar, for your great work, and you have been really providing huge energy to the working group and to me as well, and for the outstanding support from the AGI Foundation, because really AGI Foundation, Pete, Rosina were so proactive in supporting us through this third event. Hopefully, people will enjoy. If you can show the next, or it's under my control. Yeah.
Oh, there you go.
I went. It's under my control. Thank you. So, first of all, also I would like to thank the technical program committee, Professor Tinoch from Oxford University. She provided great help and great energy and support to what we are achieving these days. Roberto Morabito, Erecom, he helped a lot in on this task, but also on the white paper. And please do find time to read the white paper on the page of the working group at the AGI. And last but not least, Mike Stauffer, great presence from Mike, AGI Foundation, every meeting, and we got strong help from Mike, and I'm very grateful. To all these three person which really felt the sense of urgency, the support, and I cannot imagine today and tomorrow without them. But obviously, the strategic and the leader and the supporter partners have been fundamental in creating an environment in which we can operate today. So even if they were not part of the TPC, their presence was behind the curtains, always fundamental to create the space and to allow the working group, like our working group, to operate. So thanks to all of them, because I cannot imagine a different environment which allow us to operate without them. So that's simply great, outstanding. So what are the objectives? We want, Peter was really reminding this many times. After the two events, the two forums last year, we felt the sense of urgency and responsibility to provide updates to the whole community. So we need to be all up to date on different dimensions. Because generative AI and its evolution, we are entering the Agentic AI period, also is very transformative, and so we need to be up to date, and the people which will speak today and tomorrow will help definitely to be up to date, and because we are seeing also initial implementation at the edge. As I said before, sooner than expected. And this is so exciting, which means that generative AI at the edge is going to be pervasive. By the way, the cloud is not standing still. So that's a game we need to play all together as a community and look forward, look to what will happen in the next periods, and create an environment in which we collaborate together. Because innovation on that respect is something that no one can achieve in isolation mode. We need really to work together if we want to the innovation to move forward. So without barriers, with a sense of community, unprecedented sense of community for all of us. And that's I think the proof of that is today and tomorrow, and not only, certainly. So the agenda today, there is this kickoff we are just experiencing now, and then Pete and Samir Jaber will have a fireside chat, and then from Intel, Ashutosh Kumar and Raymond Lowe, Alberto Alvarez, NXP, Arniban Bhattacharjee, Wipro, and Pete Warden, Useful Sensors, and Vinesh Sukumar from Qualcomm, and Chen Lai from Meta, and then we will have a concluding moment between all of us, and in particular Pete, myself, and Ajar. So the rule of games: 30 minutes each, 25 minutes speech plus 5 Q&A. we will alternate ourselves, myself and Ajar, in moderating these contributions.
Fantastic.
And last but not least, sorry, Pete, if I interrupt you, a great thanks to all the speakers, because their help and their contribution is just there is no measure of their value of today, because they are really the actors and made that possible, and we are very eager to hear from them.
Fantastic. Hajar?
Yeah, what I'd like to add is that this forum isn't just about like showcasing breakthroughs or highlighting trends. So it's more about bringing together builders, thinkers, and doers like you to explore how we can responsibly and creatively shape the next frontier. So maybe over the next sessions, we invite you to ask bold questions, challenge assumptions, and as Danilo mentioned, the most important is to connect, because the impact we're aiming for doesn't happen in isolation. It happens together. And yeah, as just Pete and Danilo, we want to thank you for being here, and let's make this forum a forum to remember.
Yes. Sounds good. And yes, as a reminder, this is a live stream. There's questions. There's time at each talk to take the questions, which will be broadcast on the screen as they're asked. So please, as Hajara suggested, please lean in, ask questions. This is about empowering ourselves through knowledge, through some collaboration, as much as anything else. So this is not a forum to get pitched products. This is a forum to get pitched knowledge, and that's what we're going to do. So to that end, we will. I'm going to transition here and have a chat with Samir and give Danilo and Hajar a coffee break. And here we go. Oops, there we go. Okay. Sorry, Hajar. Why you keep coming back in? I don't know. Maybe Hajar is going to be here. Okay, cool. Excellent. So we're going to transition in. We're actually 2 minutes ahead of schedule. So awesome. So for those not familiar with Samir's work, if you've read the Generative Edge AI report from Wevolver, he was the editor-in-chief of that. And we're not going to get into like the technical bits and bytes here. That's going to be the rest of the morning and the rest of the day. But I thought we could start by like taking like a little bit of a 30,000 foot view of this space. And you've done a lot of work, Samir. Welcome. Thank you, by the way, for joining us.
Thank you for having me.
Yeah, and you've done a lot of work kind of looking at this space, and which not a lot of folks have done that. I haven't seen a lot of kind of analyst level reports of the space yet. So it's probably the first one. So I guess, give us kind of, as you were going through that process of compiling that report, which I think you can get it off the Wevolver site. I think it's free, right? If you give
Yes, it is. Yeah.
Got to put your email in. Then it's free. But yeah, like what were your impressions, kind of high level impressions going through that compilation of that report?
First of all, thank you for having me. It's a real pleasure to be here. And I mean, just looking at the agenda and looking at the speakers there, I mean, I feel humbled to be part of this this speaker list. But yeah, I'm a learner, so I'm really looking forward to see what comes next. But yeah, for everybody in the audience, basically my background is I'm a tech writer, I'm an editor in the technology space, and I've been writing about AI for the past half a decade now, especially generative AI as part of that as well. But Edge AI is the focus that I've had so far. But yeah, basically, if I want to start with something of a good introduction, I would maybe echo what Hajar was saying with a quote that I had in one of our recent reports, and it's from a study that I got from IEEE researchers. They said, and let me get that properly. They said, "We will witness the transformation of the network paradigm from the Internet of Everything to the intelligence of everything, in which native AI will sync from distant cloud servers to the edge of the network. Now, it's a nice way of sort of describing the current status quo of the technology, I would say, because what we've seen so far is AI has taken over so many conversations across the world, whether it's on the technical side or on the sort of end user side, or just people interested in what this is all about.
Right. Or the trade show side, like in the case of
There you
Computex,
go. Exactly.
the AI show, the AI hardware show.
Exactly. But what we've seen, I think, recently is the burst of Edge AI over the past decade or so has been really, really impressive to see. I mean, in like I said, at trade shows, you see more and more technologies being shown in that space, especially as the big players in the field, your Nvidias, etc., are pushing these innovative hardware and leading the space. Looking at how that is growing and looking at what generative AI is doing and bringing these things together and seeing where they converge and how they sort of apply to different applications, it's such an interesting thing to learn about and see the progress there. And that was our basic sort of reason behind writing that report on generative Edge AI in 2024. And that's only a part of the Edge AI technology reports that we've written over the past 3 to 4 years now. So really impressive stuff that we're seeing there. I'd love to dive into more details on that front. But how have you seen it for your side as well, Pete?
Well, I mean, it's we imagine it first, and then we kind of activate it technically, right? And I think that we've been in that process. If I think when we started in this in March of last year, the first one we did, it was very, there was some we had some live demos. I mean, very prototypey stuff, and we've seen it evolve even in the past year, how it's gotten faster and more responsive. And we've had semiconductor partners introducing parts. We'll have Intel talk today. We'll have Qualcomm, people like that, but also more standalone processors that are being tuned to be accelerating those kind of transformer models. So like the tech is sort of catching up with the story a little bit. You always in tech, everything is always overhyped, right? I mean, that's kind of the given. Everything is overhyped. I mean, even the TRS-80 was overhyped back in the 90s or whatever. So people overhype, generative AI in the cloud and all that stuff. And now there's always a little bit of, imagine this on the edge. But seriously, at this point, the technology is starting to get there, and we're starting to see some real interesting deployments and use cases. Like, will we see commercial deployments this year? I mean, I guess that's a good question for you. Do you think 2025 is the year for actual commercial deployments for Gen AI at the edge, or it's really more like a 26 thing? I don't know.
I mean, as much as I would like to say that the speed at which this technology is growing is just massive, that we will see things this year, I wouldn't expect sort of major commercial adoption at this stage, because I believe the technology is still, in a way, in its early stages. So, and I mean, it's funny because if you talk to someone on sort of the technology side, they would tell you, "Oh, we're way ahead," and people need to catch up. But if you speak with people on the end user side and looking at certain applications and use cases, it's not the same story. So finding that balance when sort of predicting, let's say, the future is crucial. But yeah, I mean, I do think the growth that we're seeing in this space is massive. It's so fast. But at the same time, there's always bottlenecks to resolve. There's always challenges to face. And Edge AI, or basically the edge, is not a small one space. There's different layers to the edge, right? You have the far edge, you have the near edge. Sure. You have the hybrid situation between the cloud and the edge that was mentioned earlier. So there's a lot of aspects to consider here. But at the same time, I think we will see some aspect of commercial adoption early on. I think the easiest places that we see that is, but it's in the industrial automation.
I was going to ask you, who's the first? What's the first sector to really embrace
Yeah.
generative edge AI, do you think?
I mean, I do think the industrial automation space is a clear sort of winner in that race if you want to sort of compare industries. But at the same time, retail, entertainment, etc. These are also very fast growing spaces and very fast adopters of technology as well, for obvious reasons. So, but I do think when we look at manufacturing, we look at smart factories, we look at how industries are trying to optimize workflows in the industry. This is a great space for such a technology.
Yeah. I mean, it's always a little, spending time commercializing some of this stuff in the past. Adoption by industrial and manufacturing industries usually takes a long time because, they have existing processes that are well established using usually ancient protocols and like a lot of brownfield deployments. And so
Right.
it's sort of like, where do you adopt this stuff first? And how do you make sure that it's, I was at a conference for aerospace, which is a very,
Right.
deliberative and kind of predictive industry, right? By definition, you need to know exactly what's going to happen for every bit that flows through that system. And AI kind of upends that a little bit, especially generative AI, right? It's not as predictive. And so I think that's also, even though maybe the chips are now here, or getting here, we have models introduced from like Google and Meta and the Falcon model out of Abu Dhabi and things like that. Lots of cool kind of more edge appropriate small language models. Maybe the technology's here, but I think the challenge is going to be the gap between the tech and the commercialization, the gap. And like you said, on the end user side, the evaluation adoption of that, probably we should be prepared. It's going to take a little longer maybe than we expect because, but that it's still inevitable. It's just a matter of when.
Yes. And I mean, I think there are two things that sort of hold back the adoption of such technologies. One is regulation. So when you're in an industry that has a lot of regulations, it takes a lot of time to allow the technology to spread through that space. For example, automotive. Although automotive is a highly technology-driven space, at the same time it's highly regulated as well. So looking at sort of autonomous driving, we've been talking about autonomous driving for I don't know how many years now, and it's always a gradual process. When you look at the technology, we're there, like it works in a way, but at the same time, having that adopted across the industry is not that straightforward, I would say.
Right.
And the other point is the actual skill gap that we have across industries. So people understanding how AI works, how to use AI to maximize the benefit of it, whether it's in their daily jobs or across sort of the sector that they work in. I still feel that there's a lot of work to do there, right? There's a lot of education necessary. There's a lot of information sharing that's crucial there. And that's why I admire what you guys are doing at the Edge AI Foundation, because you're supporting that aspect. You help sort of helping improve that education aspect, and that's what people like me as well as a tech writer try to do through these reports. Right, we try to make sure that when we create content around the technology, we're not just saying how awesome and rosy this technology is, but actually speak how does it apply to that specific application that this engineer, this developer, this person is in. How does it affect their day job? Because when you don't have enough information, a lot of people start fearing AI is going to affect my job negatively, et cetera, et cetera. But when you actually start informing people about how to use AI and how does that support their job, there will be better opportunity, better potential for skill development, for combining what AI does with the human element as well. So I think there's a lot of work to be done there, and I'm happy to position myself in that space as well to support as much as I can and contribute as much as I can.
Cool. I wanted to do a little act on the comments. There's folks tuning in here from all over. Hello, Joel from Uganda. And it's just cool to see that, this is such a worldwide phenomenon, working on Edge AI and TinyML and things like that. So it's good to see that. For me, there's sort of like three big chunks in this space that I hope we address over the next couple of days. One is like how we're going to use generative AI to augment, some of the Edge AI solutions that are out there. Specifically, I'm talking about like VLMs, basically attaching VLMs to imaging streams, so you can have context about what the sensor is seeing, whether that's an image sensor or whatever. I think that whole area of adding context to kind of sensor input is going to be a big one. So I'm looking forward to hearing more about that. And then the other one is like human machine interface. So, inevitably, if not, it's coming up at CES, is the fridge you can talk to and it talks back to you and blah, 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 which, it's going to happen. But, imagine more of like in the industrial commercial space, you're inquiring about the state of a piece of equipment, rather than putting on a HoloLens and all that other stuff. You can just, talk to this equipment and it can talk to you about what its state is and what's happening. So I think that human machine interface is a great opportunity as well. Then the third part, which is a little kind of funky, tricky, is like agentic AI. And we'll pop up a question about that. But how do these systems plug into bigger kind of agentic AI frameworks, which is really kind of AI that does stuff? And how does it play nice? I think we have a presentation from MIT on some of the kind of agentic kind of agent to agent protocols that are being discussed. So, how does a piece of edge equipment play nice in an agentic system, which no one's really figured out yet, but that's what we're here for, figure this stuff out. So those are, to me, like kind of the big three. I don't know if you have like any magical use cases in your head or that came out of your work for this report with Wevolver that stuck with you.
I mean, I agree with the big three spaces. I mean, I can maybe start from the last one on agentic AI, given how much of a buzzword this has become recently. I mean, I do mention one of our.
I'll pop that little question up from Manish.
Yeah. I mean, I think I read in a Forbes article that a quote from John Rose from Dell, where he says agentic will be the word of the year in 2025, which is, I mean, an interesting sort of idea, or it's an interesting thing to say, because the way things are, especially when it comes to terminology, the way things are developing across AI is really interesting, that you're seeing new terms and new areas of research and new areas of application quite frequently changing, quite frequently growing, and it's that sort of race of what becomes more and more commonly discussed. So agentic AI is definitely one aspect. Physical AI is also another aspect that I think is also critical, and that applies to the robotic space, right? The human machine interface that you mentioned. I think also in that space in particular, it's not just about how we communicate with the tool and tell it what to do. I mean, it's supposed to know what it does as well, given its generative AI capabilities. But I think the most important thing is also awareness. So this machine is supposed to become aware of its surrounding, whether it's for safety reasons, whether it's for taking over the tasks that humans are better off not doing, right? So sort of, if you're in a for example, exactly, if you're in a chemical setting or whatever, allowing the robot to take on that task and enabling humans to be in a more safe environment, and enabling that communication between the two is critical. And I think that's where we will see really impactful change when it comes to human machine interface. Not to mention product line sort of settings as well, whether it's in automotive or other aspects. But yeah, I mean, if I also would add to the three things that you mentioned, a space that I really feel is growing very fast, and I think it will be probably one of the fastest, and that's probably just my own view as an outsider, which is wearables. I think wearables is a really impressive space that applies to multiple industries or multiple application areas, whether it's healthcare or consumer goods, etc. And I think wearables is a perfect place for personalization and even hyper personalization, where you have, instead of actually requiring your data to be transferred to the clouds and waiting for that to come back, which is really critical in healthcare, for instance, for patient monitoring. And in these cases, I think it's really important to see how generative AI starts building more and more context around the data that's being tracked and the data being sensed.
Well, it's like the sort of like the VLM model, right? I think at Google I/O they showed that the advancements in that, where the glasses are seeing something, and of course it's the models are running on your phone at this point, which is totally fine because most people have phones. But yes, that kind of pairing of like, tell me what I'm seeing or give me context about what the sensor's picking up. You can imagine putting that in a healthcare, aging in place. Lots of scenarios where it's a very complicated set of sensors. Imagine in a hospital room where you've got hundreds of sensors happening, and using generative AI to make some sense of that, instead of waiting for the doctor to show up. Maybe there's some way to kind of get a take on what's happening there. So that's definitely a space. And by the way, yes, I should say the fourth would be physical AI and robotic space, because the ROS space, which has been around forever, and in fact, we have a pretty good white paper on that on our website about physical AI, is being transformed through the use of generative AI, and you're looking at observational learning and all these other things that's happening with Groot and foundational models specifically for robotics. Probably that's the fourth pillar of this thing as well. We had a quick question here too. We got a few minutes left, so let me just throw a few questions up here. I think Rahul was talking about Zephyr RTOS. Now, I don't think we're going to see foundational models like LLMs running on RTOSs anytime soon. However, I would say I did see a very cool demo, a private demo at Computex, that I think we'll see more public soon, around more kind of Cortex-M class processors running very pruned and limited transformer models, leveraging like ARM, U85 acceleration and things like that. So, I think in a very limited way, what's interesting about this space, especially the industrial commercial space, as you know, is it typically is very well bounded, right? So when you're talking to your car engine about diagnosing it, you're not asking it to write a haiku or draw a unicorn picture. It's trained on that data specifically to answer that. So I think seeing Cortex-A, Cortex-M series, I think we'll see those demos this year. And then we still have that gap between demo and commercialization. And is that 6 months? Is that 9 months? Is that 18 months? We'll see. But certainly this year, I think we'll see some highly pruned, optimized. But I don't know if you have did you find anything like in this space, in the Cortex-M MCU space, around generative AI yet, or is it still very speculative?
I think it's still early stages from what I've seen so far, right? I mean, but yeah, I'm definitely not the expert to tell you all the technical details, but from an outsider view, yeah, I mean, I think I'm a little more conservative than you are in terms of the time between commercialization and demo. I think it's a little longer, I'd expect.
Hopefully not longer than 18 months. It's interesting when you get into, if your commercialization window is too long, then the core technology advances to the point where you need to start over again. And this is what happens in aerospace. They have like these 5-year projects where like 2 years into it, they need to start over again because whatever they had spec'd in is obsolete. But yes, I hear you.
But I really hope it's fast enough, because I think it's critical. But like I mentioned early on, it's not just about putting the technology out there and implementing it. It's about allowing the people who are using the technology to understand it properly in order to adopt it and not feel threatened by it. I think that's a crucial aspect there.
Here's another good one. One of probably the secret weapon here for generative AI and the edge is the smartphone, right? I mean, that is the platform where it's providing the scale that is probably business rationalization for a lot of these smaller language models and semiconductor optimization, right? So what Google's doing for Gemma, and we had mentioned Meta and these other models that are out there, what Apple's doing or trying to do maybe with Apple Intelligence, and obviously what Qualcomm's doing on Snapdragon. I know they're going to be talking in the next couple of days. The smartphone is actually providing sort of that scale economic engine for generative AI on the edge, where there's high volume. Now, use cases are interesting. I don't know if I see the summaries on my iPhone of different messages, and I'm like, not sure if it's super valuable, but it is providing scale, and I think that's kind of like the secret weapon of generative edge AI is smartphone scale is going to justify these other deployments that gives people sort of the economic justification to do more work in this space. But I don't know what your take is on the whole smartphone market and generative AI, how much it's going to transform it or not. I don't know.
I mean, at least I agree with what you said. I mean, but just looking at what Google has done, I mean, Google has been in working in the AI space for I mean, much longer than a lot of us know. They've been leading this even in the background very, very early on, and seeing how they're even collaborating with other hardware companies. I mean, only recently I've had the chance to speak with Synaptics on their collaboration with Google, for instance, and how they're combining sort of the models from Google with the efficient hardware from Synaptics, which is really interesting. So I think a lot will progress out of that. I mean, when you see the big players pushing these, it usually works. It usually moves forward for obvious reasons, whether it's the money involved or they see the power of their coverage. But yeah, I mean, I do think smartphones will still be playing a big role in this. They will be. I mean, I don't see them out of the question in terms of how they're going to be used within Edge AI sort of applications. But yeah, let's see what comes up. Right? It's such an exciting space. So
I was going to say the other economic engine, scale engine that's going to help drive more development here is just the PC. So the AI PC, Copilot PCs, we're going to have Intel presenting too. And, the ability to run kind of these smaller language models locally in PC environments as well as smartphone environments will springboard into other things for sure. And I even saw it. I saw it at Computex. The Intel booth, by the way, was packed. Literally at Computex, it was like shoulder to shoulder. It was like bumping, it was like I felt like a pinball in the Intel booth because I was bouncing off of people. So it was pretty amazing, like all the stuff that they're running there. And I think that's all going to translate into more of these commercial vertical things and even down to like wearables and things and like, running VLMs off your phone that's connected to a wearable and stuff. It's going to be happening. So I think the PC space is definitely an engine for acceleration. I actually saw an interesting example, and it was I think a lot of us use these note taker apps now for our, like Google Meet has it, and Otter and Firefly, and it's kind of ridiculous. But someone wrote one, and I'll name drop. It's called Backpack, and it's really how do you do like note taking on your personal device, not on the cloud. So it's running a Gen AI model locally to transcribe and provide context around conversations without that data in the cloud. And it was actually sold into like the financial analyst community or financial advisor community. So you imagine you want to do a private thing. So interesting, maybe a little niche, but again, it's going to exercise that equipment, exercise the models and the PCs and phones will be plugged into agentic systems. That'll probably be the first ones that become kind of agentic endpoints as well. And that'll help then figure out like, okay, how do we actually wire this stuff up to be first-class citizens in kind of cloud-based agentic AI. So we shouldn't count out the smartphone and the PC are sort of the secret edge weapons, even in the tiny ML space to sort of provide the economic scale. So keep an eye on what's happening there, because that's kind of foreshadowing, I think.
Yeah, I mean, one last point on that is that, I mean, looking at the area of smart homes as well, I think that connects quite nicely to smartphones as well. So I mean, I've had several discussions over the past months about smart home applications and how sort of AI is being implemented into that space, and whether it's within one particular device or actually across the whole setting that you're in. I think there's a lot.
I saw a few of those kind of home gateways with generative AI, where you could sort of talk to your house and blah, blah, blah. I'm still trying to make my lights to work, but that's a whole other.
And there's the multimodal aspect, right? That's where I think things are really growing. So
and providing the kind of really language context around the sensors of the home.
Exactly. Yeah.
Interesting. Yeah, that might be an interesting commercial deployment, and I'm sure it'll be foisted upon us by the next Xfinity cable modem update, whether we want it or not. But anyway, just as a note from Bill here on privacy is driving AI to the edge, right? And so, like, how do you kind of have control over your models and your data without sending it out to some anonymous cloud? So for sure, totally. Hey, we're coming up on time, but hopefully this was a little bit of a amuse-bouche, or whatever the term is for the rest of these conversations, which people will really dig into it, but really think about what's happening out there and all the stuff that's going to be on the palette for the next gen. So thank you, Samir. Really appreciate it.
I appreciate having me here. And just a note to the audience: if there are any questions that we couldn't answer now for the sake of time, check out the reports that we've developed. Really, really in-depth reports there. You can check them out.
Awesome.
Appreciate you having me, and look forward to the other speakers.
Thank you, Samir. And Danilo, I'm going to hand it over to you. Before I hand it over, I do want to do a public service announcement. For those that this is all fun and games here because we're on the internets. But if you wanted to actually meet in person, we have a 3-day event coming up in Milan, July 2nd through the 4th. I know, Danilo, you'll be there because you live there. But it's a 3-day, basically it's like 45 sessions, 8 workshops, panel discussions, some really good coffee. And so if you go to Milan 2025.edgeaifoundation.org, you can get some tickets and meet all of us in person and have those discussions and see the demos and all that other cool stuff. So that's my PSA before I disappear. So Danilo, why don't you take it away?
Thanks a lot, Pete. It was great to have Samir today with us. And please come to Milan because the weather is fantastic. The venue is awesome. And there will be a lot of contributions and interesting talks and other things that you will certainly enjoy. So welcome to Raymond Lowe, Intel. He's going to speak about building your chatbots with OpenVINO and the EIPC. Raymond, thank you. Welcome. Thanks for being with us today. And you have 25 minutes plus 5 minutes Q&A, and the floor is yours. Thanks so much.
Perfect. Thank you again. I'll have a lot of slides, so bear with me with the slides today. My name is Raymond. I'm from Intel, and I've been with Intel for the last 5 years, almost 5 years. So if you're interested in what we're doing, follow me or our team on LinkedIn. You'll see a lot of news about what we're doing at Intel. So oftentimes you'll see a post from me before there's an announcement somehow. So for example, I work on OpenVINO a lot. So a lot of pre-release material, sometimes I test it out and you can see it. But to no further ado, let's talk about chatbot. People call it agentic sometimes. For me, it's really about how can we talk to a computer. And today we'll talk about that because having a machine talking to you was not easy. And when it does, it's very powerful. So let's think about journey yourself. I've done a lot of different programming exercises since I was young. But one thing really intrigued me today is we can really have a good interactive experience with computers. I remember the first time when I get a computer, you get a mouse and keyboard, you click on it, type some document, it feels good. But what if we can have a proper conversation, and what that brings is an experience like going to the hospital, for example. How many times you walked in, you're trying to figure out, okay, who should I talk to? Where's the nurse, right? And then oftentimes you go in there, the nurse may ask you, why are you here? And then, of course, we're sick. Of course, we are not feeling comfortable. At that time, I think if we can reduce some of these wait time, I think there's a lot of huge benefit from building such chatbot or assistants, we call it sometimes. And my brother's the doctor, right? We saw a lot in efficiency in the system, like especially for note taking and things like that. So as we see today, this is becoming a reality. I see, actually, when I see the doctor last week or a couple of weeks ago, I walk into the office, I saw the person already turn on the cell phone on the edge, recording our conversation, transcribing, and making a better experience when things are needed to pay extra attention to. I think to us at Intel, this is a great opportunity because your PC, what's sit in front of you, could be the best companion. And why I think so is they're not just talking, right? The chatbot, of course, you can do large language model. When I first started, I thought Llama 2 was like almost Asian time, but it was not answering great questions sometimes. It was like off track, hallucinating. But today, if you look at what Microsoft released, for example, 3.5, they can answer better question even with images. So imagine now you put the questions about like what's happening to my eye. They actually can do better. And we saw just last week I was at Microsoft Build, we saw scientists are using these tools for discovery and more and more. And that's why I think about chatbot is just really like, how can we have a better way to communicate with computer in a deeper way, right? Think about even doing research and thought processes. And for consumer, I don't know if anyone have babies here. I do have a baby, and it's 1 year old. And the number one question I get asked by my wife a lot is like, what's my baby doing? And imagine we can have smart camera that you can set up without coding. All you need is put like a large language model behind it, like with a visual language model. And then you can have questions like, oh, my baby was trying to play with the computer, play with the keyboard. And that's something actually we're seeing on the edge. It's like, hey, we can actually make extremely smart computer without a lot of like computation power it takes. May not be very accurate, but we're just the beginning, right? And then how much more we can get within a year, that's something worth thinking about. And one thing I think a lot of us, like when we build a lot of assistants on the edge, is you never have that big enough model. You always have a small model that actually can fit into the memory. You may have like maybe more limited reasoning. So we also see the next generation is more like agentic with RAG on top. So why that's important is we test a lot of these. For example, in this case with Llama 3, 8 billion, it works extremely well for, let's say, simple use cases. And when you have RAG, which allow you to augmenting information to the chatbot, like for example, ask what's AI PC here. It will not know it if I didn't give you the document, right? So, and it's important in the edge use case. Maybe sometimes you want to provide extra information, so then it actually be contextual aware. Think about you in a restaurant. You want to build something that with your burger menu, and we can do that now. We can do it extremely well with RAG and also some agentic chatbots. To the very final piece, when we think about compute at Intel, we've been supporting a lot of different models. And then again, I talk about OpenVINO, I haven't introduced it properly. But what we notice is we accelerate some of the work so well that only a couple of years ago, or a year or two ago, these are not even possible locally. So what you're seeing on this computer right now, which I capture on my own machine, I'm running one of the image generation on the local GPU, the iGPU. I can generate this beautiful teddy bear in about 8 seconds. 8 seconds, like finally, like a beautiful teddy bear that's faster than any human drawing ever. And the quality is as good as some of the photography I took myself. So that's very intriguing. And the same source code, if you upgrade your GPU, I don't know you ever follow the Intel Arc trend. I'm the fanboy. That thing is a beast. It has 16 gig of RAM. It actually, like a couple of years ago when it released, actually, we start building AI examples on it, and then we realized they're super powerful for the price point we're giving. So that's another great example how we see programming like a chatbot or creating very interactive material on the edge. And the GPU you have today on your laptop most likely is sufficient. And in this case, we can finish this in 2 seconds, as you can see, very fast. So this brings to the very important question is like, what is happening at Intel, and then what happened to some of the work we have done? This is very new, by the way. I just released this last week. We talked about a Microsoft build. We are now collaborating with many great customers and partners. And then one thing we collaborate on is a lot of software component that you may not have heard about today until maybe now is Microsoft released something called the AI Foundry, or we have the Windows ML. What we have done is actually we have put some of our technology, for example, OpenVINO, quantization here, you can see at the left. And then also we provide our runtime to the Microsoft ecosystem. So later on, when you buy your PC from, let's say, Best Buy or some other, maybe Costco, it will preload OpenVINO for you. And when you download your model, you will get the best performance out from it. I think this is a life-changing for me. When I started at Intel 5 years ago, we joke around it, right? Why don't we have this pre-installed at Windows? I think it's not a joke anymore. So it's happening as we move forward with, let's say, the new way of thinking about building software on PC, especially on the AI front. The model will be pre-compressed for you, and then we'll have a runtime that always ready, so you get the best performance out from your silicon. So, and this is something I spent 2 to 3 weeks to get from our engineers. So if you really wonder how it works under the hood, I bring it to you. So my background is software engineering. So when I see diagram like that, it makes me happy. Feel free to take a screenshot of this. So this is under the hood. Come to our webinar, we'll talk about this further. But for now, I think this is a great example how deeply we integrated into some of the work in Windows and others. Of course, our work works on Linux as well, if you're interested in having portability. So I talk about a lot of benefits. I talk about why we're here, why we're in the edge. But what's OpenVINO? Why are we here talking about this? And why do I promote this? So think about all the great examples you saw can come from different models, right? We can have PyTorch. We still have some TensorFlow model coming in. For example, some of the old school gesture recognition stuff was from TensorFlow. And we have AllNext, of course. We have even Paddle from China. All these models come into our Intel Silicon. Oftentimes, they're not optimized, right? So that's what OpenVINO has been doing. We're to really compress this model, making sure that it fits into that small size. Could be your small laptop, can be on the cloud. That's what we've been doing, right? We have a portfolio of hardware from Intel. So if you think about Intel, we don't just build GPU, we don't just build CPU, we build a lot of things from the edge to the cloud to the client. So when we think about this coverage, what OpenVINO has been doing is we bring this optimization code, which under the hood is one API, or a lot of these kind of like open source standard work we have done. We distribute across different hardware here. In this case, we even have NPU, which is a new silicon that we provide for high efficiency, low power on the edge devices. And then we started that a long time ago. We call it the VPU. We call it Movidius. So at one point, if you are following us on Raspberry Pi, people plug in those USB key that has actually our NPU built in. And then we can get really good acceleration. I think it was like 10 times faster than the Raspberry Pi for only 5 watt of like power. So that was like one of those accelerators we provide. Why this is important, I think, to us is when you have this cross-platform, cross-OS, cross-architecture, and then cross-models, we have a very powerful tool that you can build many things or anything, if you can imagine. And remember, my thesis is about having communication with the computer. So you can have use cases that actually were only dreamed about back in those days become a reality. For example, from computer vision has been very, from old school YOLO, which is almost 10 years ago, we optimize it really good to natural language model that we talk about. Maybe back in those days, we call it BERT as well. We can have now above and beyond with simulation with robots, chatbot we talk about. We can even do voice generation and recognition very well. And then well, I think if we're going to talk about this, we can even do code generation, so you can do coding with it. There's a lot of these possibilities are getting explored and also be deployed on the edge as we see every day. So today I lost count how many. Back in those days, we say we have 1,000 of these models. Today we don't even know. Well, we have this huge pool of open source and cross-platform models that you never see. And a lot of time, I think we always think about when you have all these examples, right? This is an open question to everybody here. Where do I put the compute? Honestly, for the many years I work in either before Intel, I was doing my own startup today. Putting the compute in the right place is never an easy question. It's the hard question and never an easy answer to it. So today we figure out some of it because when we build the silicon at Intel, which is what I like my job a lot, it's like I see this new silicon came out and then, hey, there's things that we couldn't believe it was possible before. For example, when we do dev estimation or post estimation, back in those days when you're trying to do it on the CPU, it was very slow. It's not interactive. Today, when you bundle with the NPU, it can be low power, it's real time, it can be simply just like running behind the scene, like in the background for you, while your CPU and GPU are resting happy. So there's like possibility that we didn't know it was such a great idea. And especially background blur. You see my background blur. It's amazing for the NPU because it's not, you can have 4 hours meetings of one because it will use a lot less power and then your battery will be very happy. And think about this compute. Where do I put that? I think this is where I think OpenVINO give you that flexibility. You can switch between this model, that model. And that's where I think the beauty about what we're doing. So I'll take a pause. I'll read some questions that's in the Q&A. Then I'll talk about something really hard. I gotta switch myself to the browser. I'll take a look. I think also we have Ashintosh behind the scene. Actually, Ashintosh has been answering questions. She's from OpenVINO, from Open Edge platform. So we work together, and then thank you for sharing some of the links. I guess we handle the Q&A. I'll keep going first, but I think people always ask like, so like, how do we use NPU? How do we do that? A lot of time, I think you don't have to learn it. That's a beautiful thing about what we're doing. We try to simplify some of the developer workflow. So then we handle the compression and handle the deployment for you. And we put an open source library. So if you really care about performance, like you look at the clock, I have like only, let's say 2 seconds to run this work task. You can actually go into the open source code and figure out where's the bottlenecks are as needed. In this case, with the library we use is called NNCF. This is neural network compression framework. It does amazing work on making the model, for example, doing quantizations. So from 32 bits to in8, and for, let's say, a large language model, we even do down to in4 with different algorithm behind it. Why that's important, I think, there's a lot of techniques which I actually have a lot of tutorial talk about those. So we'll talk about this later in the slide, so you can learn from what I'm talking about here. The key is, with the optimization, is basically means you're only use half your hardware most of the time, or less. Because under the hood, when we think about innate, it's not just the quantization, but under the hood, the silicon has the computation unit specialized for the innate instructions. So for Xeon, for example, on the cloud side, innate is a must for AMX to activate it, which is the AMX, the VNNI at that time. ANX, you can also use it for different polling point as well. But for great performance, I think innate was the great starter, because a lot of time I talked to real developer, they didn't know you're not losing that much in terms of the accuracy. Sometimes you may be doing better or some computer vision task. It's weird. It just happens. Sometimes you actually becomes a denoising to the model because doing the quantization, something happened to it. So you have to measure yourself to what you're doing. But that actually is important for use cases where you may only get like 20 frames per second, and offset in that 2 to 3x boosts you to real time. And then you have a very different product as an outcome. And on the edge use case, you cannot put 3 times more CPU or GPU on it sometimes. You may want to think about this, right? How do you get 2 times more? It's actually a lot more expensive. in terms of power, in terms of the cost. So the software, don't ever underestimate. And when we think about this, it's like when we do quantization, when we measure it, especially for YOLO, those type, I think you just have to do it. That's my word to it. Depending on use case, of course, but that's definitely worth your time. And then we provide all the source code here, for example, you can learn, and we've done it and measured for you. Why that's also important for large language model? We talk about chatbot experience, right? One problem that intrigued me a lot were when we started this a couple years ago, I think almost 2 years ago, when we first looked into large language model, the first problem we dealt with was not the computational problem first, was it didn't even run. It will just blew up the memory, let's say, especially with GPU at that time, and then it stopped running at all. So we start really figuring out the runtime, how to ensure that we're not making extra copies. But at the same time, we're going to have the first step is, if you look at the Llama 7 billion, right? If you look at the 32 bits, I don't know if a mouse works on top of it. It used 25 gig of RAM. I don't even have any graphics card that closes that range unless I go very high, expensive one. And they don't even work that well for 32 bits. So there's a lot of gaps on what the world is giving you, especially on the model side, and what is deployable. So at that time, 2 years ago, it was an interesting time when we do a keynote. So behind the scene, I was one of the lucky ones to hack it, working with the driver team, working with the runtime team, working with the application team to make one demo to run Llama. And it worked. When the first time I see the computer, the laptop, pumping out, I don't know, 1 token per second or something like that, I was like, carry my laptop, bring it to my wife, and say, oh my God, the computer is talking to me. It's like a human. It's a bit slow, but it's still answering my questions, be able to put a sentence together. I think that's where I think there's a lot of like, it's not just a hype, it's just like, it's real. It's actually solving some of those small problems. But if you can solve these well, and then we can collaborate, maybe you can solve big problem. I think that's how usually all these chatbots come together. And that's exactly why we have Infor, even different algorithm. This is actually doing asymmetric group 128 different ratio. We want to measure the impact to the model when we compressing them. Why that's important, I think at the end of the day, RAM is RAM. You don't just double it overnight. But if you do right software, do the right algorithm, you can reduce it significantly and without huge performance impact into the model accuracy. I think that's a win-win for what we've seen. And that's why today, when you go to AIPC, a lot of model runs extremely well. It's thanks to the engineering work. If you, however, don't know if your model is working, we did put together a lot of different benchmarks. That's what I love about Intel. Sometimes we are very interesting about like how we approach things. We just did the work and we didn't talk about it a lot. So in here, we have one of the largest database of model, actually, if you go back into the AIPC thread or some of the model we have optimized, thousands of them for sure. But if you search for just AIPC, you can see how well some of these models can run. So before you fine tune your stuff or anything, you can predict the outcome, how well this model will run on your machines. I think that's very powerful, especially today. We also work with Microsoft, as I said, right, and many different partners. Some of the model when we optimize, we actually benchmark for you. So when I say benchmark, means we don't just like, hey, it's run this fast, but we benchmark against different parameters. So think about this is almost like a hyper parameter style, right? You just explore all the options in the pool and then look at the impact toward the final outcome. So if you go back to NNCF, the library, if you look at our documentations, oftentimes you'll see even the model we pre-compress, pretty much like we try to see where's the sweet spot for you. So where do you find more of this? You can go to Hugging Face, look at OpenVINO, and then we have a shared repository with some of the pre-compressed model. And that way, then when you start using Intel hardware, you know that you're getting the best software. Take a screenshot of this. This will save you a lot of headaches. Well, at least my headaches, and then will come through very well when you are prototyping, when you are doing any sort of work at Intel or related to Intel, or not even Intel, maybe even ARM platform. So I put together some examples. So I don't just talk, I create a lot of examples. If you're interested in trying what I just talked about, I put together scripts you can double click and it'll run. It'll install, it will download, and it'll run those 3 steps in the bat file. So this is the link to it. Enjoy the code. I did that 2 weeks ago, 1 week ago. It should still work. 1 year later, I don't know. Maybe things will change. But last week I tested and it works extremely well on your laptops. Make sure you have 32 gig of RAM. 32. Okay. And when it runs, it not just run on CPU. This one will run on NPU as well. So when people ask like, would this run on NPU? Yes, it does. When do I use NPU? Depending on scenarios. So in this case, I asked the machine to write a song about AI with emoji. I don't know why, but it worked. It's kind of fun. You can sing with it. So now sky your limit, right? You can be very creative, build your own DJ, sing a song for you. I think it's fun for the kids these days because they will open up their imaginations. And then for my 1-year-old, I got to teach them how to use GenAI now. Chatbot to do something fun, just like have like an interesting learning experience, but not fully relying on it. I'm just saying, just to have exploration. I think that's where curiosity, right? And if you're interested in what we just saw here, we also build, not just I, as a team of us, build a rack demo where you will see how we bundle this with our partners, like I shouldn't say partner only. It's just like all the community of members, right? It's like anyone that using the tool, like from LangChain, Llama Index, we integrate with them. So then you see our presence of OpenVINO in those large language model tools. And that's important because you don't have to relearn. You can use what you had, but you just have to make sure you enable the right components. And that's going to give you the accelerations. And as a homework, I'm closing in 2 minutes. We also have example on the edge side where you can do agentic workflow. So this is real. Like you can talk to a chatbot locally that you can order some paint, and then I don't know why you want to paint your house today or not, but it's a great experience you can try to see what a chatbot can do locally. This one's a bit slower because we have a lot of extra deep thinking process. Slower means like we use a very big size chatbot, but as the silicon move forward, this is pretty fast already, but it'll get even faster on the edge. Make sure you take a screenshot of this one. And at the last minute, I think I'll do some closing. First, learn the notebooks. That's where you learn 100 examples. And we have an open edge platform that you can use to also learn how to deploy this on the edge. So if you Google open edge platform from Intel, you will see it at GitHub as well. As a closing, as a benefit, right? I have 6 benefits here. 2, I think you have to remember. Memory. If you don't have memory footprint that's sufficiently well managed, it will not run well. That's what we learned for the years of trying to optimize it. We got a lot of speed up by learning how to manage our memory. A lot of things are memory bound. And learn how to deploy on different platforms. You never know what people need. Sometimes CPU is busy. Sometimes the GPU could be busy. Maybe use the NPU as you're offloading. So we saw gaming as one example. People want to use the NPU for analytics. You don't want to touch the CPU or GPU. And then having this as scalable, I think use open edge platform, as I said, is very important. This is the key. Please download and try, give us feedback. We open source Getty, which is an amazing tool for training and deploying image model. We open source many great tools like orchestrating different like edge nodes and all that. All the things that I think will take you thousands, maybe hundreds of thousands of hours to build, we put it together into a platform for you. And if you try it, you don't like it, that's okay. We'll be here listening and then we'll make it better. That's what happened at OpenVINO, right? In the beginning it was a bit rough, but now it's very smooth edge. That's all I can say. If you're really interested in what we're doing in the last minute, contact with us. I think I spent my 25 minutes if I look at my clock correctly. Am I right?
Yeah, thanks. Great talk, Raymond, and thanks also to Ashutosh who followed with the different questions.
Thank you.
Great talk, really. Maybe I have a couple of questions for you, Raymond. Really, you provided a lot of assets and a comprehensive description of OpenVINO, but there are different type of industries: small, medium, and large industries, which are spending time and efforts on familiarizing with what you call conventional AI. And so, what's your take on about the messages for these guys, one instead of another, to move forward on generative AI? Why and how these guys should find time to use OpenVINO and the great assets you described?
So I think that's a very good question. Like, it feels like we dropped the ball on the deep learning stuff that we did 4 years ago, 5 years ago, right? All of a sudden, we have this Gen AI, everyone just talk about it. And then what happened to the people already spend a lot of money and time on the deep learning side? I think first is if you're already like doing work that is functional, like license plate detection, we deploy so many of them, we forgot, right? There's a lot of the smart city idea that we use for retail. They work extremely well. I think those, I think we just need to make them better. So when I say better means, oftentimes I see Gen AI keep be the one that open up the flexibility of some of these approaches. A famous one I would say, for a lot of these, again, I'll go back to the YOLO one because a lot of people know it. You need to find your model before it works. You need to do a lot of extra work to ensure the model is tuned to the application. They're not as flexible, right? Flexibility is not built into the architecture itself. So for those use cases, I think people should start realizing that this new wave of this approach can create flexibility. I think this is the step one is, when I think about generative, a lot of things are a lot more tunable. I say tunable, like YOLO, for example, if you do it right, you can automate the fine-tuning step with the agentic approach. And then if on top of that, I saw the one called the YOLO E. They actually combine the YOLO, which is like, hey, you can recognize a dog and a cat. What if you never seen a banana before? Now what, right? It's like a banana is off track. So we can actually do a prompt injection, prompt based one. They basically combine and the tool called Clip. So then they can now recognize something looks like a banana, and then you can say banana on a table. It's like, it almost looks like a generative AI. It's like you're generating the model, kind of like structure on the fly. But you're using the YOLO architecture, so it's very effective, very efficient. So I see the industry should really think about how can I create better efficiency on some of the older stuff we have done. I don't think they're obsolete. I think they're still serving a purpose, but how can we reduce some of the time spending on that? And then also, I think my title was Chatbot. How can make it communicative, make things more interactive? The whole point is not like, I don't care if it's agentic or not. Can I make a good experience from the user? It's the number one rule. And before with the older one, they're very limited. Now we can create experience. This is, I think, the key turning point. I never felt so alive when I saw the machine talking to me, right? I think my kid will be like, yeah, Dad, I saw the machine always talking to me. It's like, but I spent the whole 40 years of my life never seen a machine talking to me. So I don't know if people forgot, like, right? So it became a new norm. But like back then, the machine doesn't talk. They just, randomly jiggling on things. I don't know what they're talking about. Anyone use Microsoft Word as a little icon with the cookie thing? Something just never answered my question when I started computing. Anyone use a Microsoft Word at one point? There's a little bit help icon. They never helped me. Not once. But I'm not saying Microsoft is bad. But that time, I thought AI was broken because I asked for how do I do this? It will give me a wrong answer all the time, right? But now we're getting too close to the right answer, closer and closer every day. Anyway, so that's my take.
That's fantastic. Thanks, Raymond, for elaborating so much. Maybe another question, more related to OpenVINO. Imagine I am a young professional and I would like to leave my footprint designing a generative AI model, how OpenVINO allows me to ease this task?
To start, I think the starting point with OpenVINO is really, again, like OpenVINO is like a step forward to make sure that you get the best performance out. But I think over the year, we changed a little bit, right? We actually have the most number of examples you ever need. If you look at the notebooks, we have about almost 200 of them. And we have our reference design kit. We have another 20 of different examples. I think we built one of the most comprehensive library of things. People, like anything you talk about, you tried it. Most likely you've seen one copy of that on OpenVINO. I think that's like, it's almost like it gives you that library of material where you can dream without, like when I was doing my PhD, I spent 2 weeks just to figure out how to run the CUDA code, just to get it running. Not even just getting it at the performing, it's just get it running. And then I spent another 2 months to get it performing. And then I spent another year to make it actually publishable, right? So there's a line for idea to executable to actual deployable. It takes a year at that time when I started. And of course, there's a CUDA step 0, right? But similar here, right? But with OpenVINO, I think in a couple of weeks, I think you'll be able to pull out some amazing demo. Like, I've got to tell an industry secret here. Every demo I build takes only 2 weeks because I have to catch up with the industry. Like every single thing is 2 weeks. So in 2 weeks, I can spin something out. How? Right? Do I write from scratch, optimizing everything from scratch? No, I have to use the tool. So this is a secret. If you are starting new today, start with a fresh ground where you can be competitive with others. I think that's a great starting point. And that's why we're doing this. You go to OpenVINO notebooks, make a contributor. So we started with 5 contributors, including myself. I have 120, something like that. Be one of the contributor. Do Google some of the code with us. Like we have some student programs. So learn with the expert. There's a lot of things you can engage with us. That I think add me to LinkedIn, you will see it. There's a lot of different posts I made about how to engage with Intel.
Yeah, that's great. Also, that the fact that you mentioned the students programs, and because we need educational contributions for people who are approaching.
Yeah, we've done it for 4 years straight. So, and this is gonna be 5th year next year. So you can take a look at the link, follow us, and then you get paid by Google to work with us. Win-win-win. So, all right.
That's good. That's good, Raymond. Thanks a lot for a great talk, and Ashutosh to support
as well.
all the Q&A. And thanks. I hope you will stay with us during the day. And now it's time to switch to Alberto Alvarez from NXP. And hi, Alberto. Thanks to join us and for finding the time to present Generative AI on NXP microprocessor, bringing intelligence to the edge. The floor is yours.
Thank you very much. Hi, everyone. My name is Alberto Alvarez. I am a systems and applications engineer at NXP. And today I'm going to present a little bit of what we have for generative AI on NXP microprocessors. So today's agenda is the following. We will briefly talk about the background of AI at NXP and specifically about GenAI. And then we are going to introduce the EIQ GenAI flow. After it, we are going to share with you our latest multimodal GenAI at the edge demo. And finally, we will give a very brief summary of what was presented and have a brief session of Q&A. So we are very excited to share this with you. So let's start with the background. So we know that AI spans from training in the cloud to inference at the edge. And at NXP, we are mainly focused at AI deployment, and that's given our robust processing capabilities that provide a unique opportunity to shape the deployment of AI at the edge. NXP is not in the business of training huge models on the cloud and then running them with these big GPUs. Instead, NXP is targeting opportunities for private, secure, and efficient AI inference at the edge for areas such as industrial automation, smart homes, smart cities, autonomous driving systems, and among others. So we know that every day we hear about AI. A new model came out from XYZ paper, and specifically, GenAI is just growing exponentially. And NXP is very aware of it. And this is why NXP is bringing these large models, the LLMs, the multimodal LLMs, to the edge. And with the introduction of all these new models, multimodal models, and also the discrete NPUs, very powerful NPUs that allow us to accelerate these models at the edge, the possibilities of creating new solutions are just expanding every single day. Let's just think about one example, mobile robotics. So NXP can now give a robot the brain, an LLM, to have smarter capabilities of reasoning. But not only that, we can also give it the eyes, the ears, and the mouth to be able to interact and analyze its surroundings and then become a smarter robot. Another example could be with superior reasoning and visual analysis. And this can be enabled with multimodal models for vision. And let's just think about having a smart assistant for medical applications in the healthcare industry, where you can have preliminary analysis of diagnosis with images. I mean, the possibilities are just very uh, are a lot. So this is just a small list of them. It's not an exhaustive list of examples. But anyways, NXP is targeting at these kind of applications and trying to leverage all the big models that are coming out in the large community of AI. So now let me introduce the EIQ GenAI flow, which is a software pipeline that NXP offers to our customers to be able to create new smart, intelligent solutions with our i.MX SoCs. So EIQ GenAI flow mainly targets two capabilities. The first one is fine-tuning and then optimization. So fine-tuning allows our customers to enhance and adapt the openly available LLMs for specific use cases without exposing their private data to anonymous servers. And by doing this and fine-tuning the model, it will reduce the hallucinations and the errors during the reasoning process, which is particularly important when applied for medical, automotive, or factory automation solutions. The optimization is also a very important key aspect of this pipeline. We know that without optimizing our models, the memory footprint, even for the smallest LLMs, is just too big for edge deployment. So we have the capability of quantizing these LLMs into 4 bits or 8 bits by maintaining the accuracy of the model and then accelerate these models with powerful NPUs at the edge. So this particular pipeline, we are releasing the first version for i.MX 95 SoC. And we are going to very quickly go over this end-to-end pipeline of EIQ GenAI flow. So yeah, as I mentioned, the very first release we have published last month is for conversational AI. So we are using audio to process the entire pipeline with ASR, TTS, RAG, and then generate a very seamless response out of the system. So how this works? So we first need a wake word engine. In this case, we are using VIT, which is a technology from NXP. We are not going to cover it in this presentation, but basically it allows the system to start listening to the incoming audio. You can trigger it with just one word. Let's say, hey, NXP, and it will start listening to the audio. And then the automatic speech recognition, it's going to convert the incoming spoken audio into text that then can be interpreted by the LLM. Together with RAG, we can enhance the LLM with specific relevant knowledge for our use case application. Again, this knowledge is not previously seen by the LLM during the training process. This is something you can do offline and not expose your data to the cloud. It makes a very private implementation and solution for everyone. And together with RAG, so the LLM can generate a response based on the input context that was given to the system. And finally, TTS is going to convert the response that the LLM generates into speech. All this is currently available for you for i.MX95 SoC, and in a few slides, I'm going to share the links with you so you can go and access and play with this new technology. In the future, we are also trying to implement the more ways of utilizing this with text, image, video. So the idea is to eventually have a multimodal pipeline for EIQ GenAI. Okay, so let me go deeper into each of these components. Let's start with ASR. So ASR, as I mentioned, it converts the input language into text. We are using in this implementation the Whisper architecture. The model that we are using has 244 million parameters and is quantized into 8 bits. And with this, we can have real-time speech recognition at the edge. The system will encode the audio in segments of 3 seconds, and for each segment, it's going to predict multiple words. NXP also offers the Pro version of EIQ GenAI Flow, and it will allow you to explore more ASR models and also personalize your ASR models with tuning. Now, the LLM that we are using in this implementation is the Nube 3. It has 500 million parameters and is quantized into 8 bits. And with the LLM, we can have very coherent responses with natural language, depending on the context that we are utilizing this in our application. And NXP, it's optimizing these models to be able to perform fast in our SoCs, accelerated by our NPUs. So this model is accelerated by the Neutron NPU, which offers 2 TOPS of compute power. And we can see in this table that when we run the model on the CPU with 6 threads, the time to first token for this model is around 1 second. So it will take around a second to start generating the first token. But the CPU load is very high. We see that we are utilizing 60% of the CPU, which might not be desirable for our application, right? So now we can accelerate this model with the Neutron NPU and reduce the time to first token by half. So now it's twice as fast as the CPU execution. And the key part is that we have offloaded a lot of the cycles from the CPU, and we can utilize this CPU for other processes in our application. So yeah, we're moving forward. We know that in the future we will even optimize further these models and will be accelerated even further. All right, so now let's talk a little bit about RAG. So we already know what RAG is doing here. It's basically enhancing the knowledge of the LLM to be able to generate very accurate responses in the application with specific knowledge that we don't want to share with any anonymous servers. But NXP is providing a tool that you can utilize to build and create a database that's fully compatible with our pipeline, with EIQ GenAI Flow pipeline. So you can very easily start creating an application that's going to utilize all these GenAI tools at the edge. And you can go and check it out at the links that are in the next slides. So you can start building your database and you can start testing this with an i.MX95 board. So yeah, very, very interesting things that we are starting to build. And finally, TTS. So with text-to-speech, we can convert the output text that the LLM is generating into speech. So The model that we are utilizing here is based on a bits architecture. It has 19.5 million parameters and is quantized into 8 bits. And the Pro version of EIQ GenAI Flow offers more voices selection options and also supports more languages, not only English. So with TTS, we can synthesize the text that the LLM generates into natural speech. So it will give a very seamless interaction for the end user. And yeah, so I'm just giving a very brief overview of what we have created with EIQ GenAI Flow, and we are very excited to start seeing what our customers can develop with these tools. So we invite you to go into our application Code Hub and look at what we are offering for EIQ GenAI. This is a demonstrator demo. So you can go and look at the information. You can replicate this and start using it in your i.MX95. So yeah, feel free to go and look at it and start exploring these new tools. We have presented at some events like Embedded World and CES some reference designs that already utilize the EIQ GenAI Flow. So here we have 3 of them: the AI Enhanced eCockpit, the AI Controller for Health Insights a POC, and Advanced Digital Connected Cluster. So all 3, you can go and check them out at the links at YouTube, and very amazing reference designs for our customers. All of them are starting to utilize these GenAI capabilities completely running at the edge. All right, so okay, so that was it for the EIQ GenAI Flow. I know it's a lot of information in a very short time, but at the end we can have a session for quick questions. But now we are very excited to present to you our multimodal GenAI at the edge demo that we have created in partnership with Kinara. So here we are going to show you our first demo that can run multimodal GenAI completely at the edge, no connection to the cloud, which is very private, it's secure, and it's efficient. So this is made possible thanks to NXP's partnership with Kinara, which is a pioneering company for GenAI acceleration at the edge. They have this ARA2 NPU that allow us to deploy these big models into the edge and have very efficient acceleration in terms of power consumption and performance of the entire application. So very briefly, I want to touch on what we are doing with Kinara. So we are basically scaling up our portfolio of what we already have at NXP for acceleration of AI. So we know we have the i.MX 810 Plus that has NPU, which offers 2.3 TOPS. Then we also have the i.MX 93, which includes the NPU from ARM. It's a collaboration between NXP and ARM. It's the Ethos U NPU with 0.5 TOPS. And those NPUs are very good for computer vision, but are not intended to be used for GenAI. So now with Kinara partnership, we can bring this discrete NPU that allow us to enhance our portfolio of i.MX SoCs and bring these capabilities of GenAI. So Kinara has the first version of their discrete NPU, which is ARA1. It offers 6 TOPS of compute power. And then recently they have released the latest one, which is 2nd generation ARA2 NPU, which offers 40 TOPS of compute power. And with this NPU is that we can now bring these multimodal and big LLMs models to the edge and start creating smarter, more intelligent solutions for many of the different applications we can find in the industry and other sectors. So utilizing this discrete NPU in our SoCs is it's very seamless. It's compatible with our vision pipeline, so you can have a complete accelerated pipeline with the input video stream from the camera, utilizing our ISPs, and then accelerate all the pre-processing and post-processing with our GPUs, and have the models, these multimodal models, accelerated with the discrete NPU from Kinara. So with this, we are now allowing our customers to create very powerful applications. But the beauty of this, we think, is that it's all running locally at the edge. There is no connection to the cloud, so all the data is kept very private. All right, so let me move to the next one. All right, so we are very excited to say that we presented this first demo to the open public in the embedded world this past March, and it was a big success. We had a lot of engagement from our customers and all the attendees to the event. And basically, with this, when we bring these multimodal capabilities to the edge, we can start thinking of new applications, right? Like let's think of a system that is analyzing a scene with a camera, and it's issuing reports every now and then and telling you what's going on in an industry complex, or your home. If you have some cameras in your home and you want to know what's going on, or at the end of the day you want to have a report of what happened in your house, well, with this you don't need to have a human just looking at something for the entire day. You can have a very powerful system analyzing the scenes all at the edge without sharing all this data to anonymous servers. So the video is playing. Sorry for that. Okay, so what we did with this implementation? So this demo utilizes the LAVA model, which stands for Large Language and Vision Assistance. And this is an openly available model that you can find in the open source community. And it combines language and vision capabilities to understand and generate responses based on both text and image inputs. The model internally has two components. It utilizes an LLM together with a vision encoder. The LLM is Llama 3 from Meta. It's open source, and it has 8 billion parameters. The model is quantized into 4 bits, and it's fully accelerated by the ARA2 NPU. And the vision encoder is Clip from OpenAI. It's also openly available for you to use. It's open source, and it has 428 million parameters. This model, we quantized it into 8 bits, and it's also fully accelerated by the ARA2 NPU. So altogether, Lava is running at the ARA2 NPU, and this is made possible thanks to the 16 gigabytes of DDR memory fully dedicated for the models. So that's in the discrete NPU. In this image that you see, we can show the ARA2 NPU. So the models are fully loaded into the DDR, and that's why we can utilize them very efficiently. The performance of this model in the i.MX 810 Plus Freedom Board with the ARA2 NPU is the following. We see that the Clip model is extracting the features of the image in around 430 milliseconds. So around half a second, very, very quickly. And then the Llama 3 model with 8 billion parameters, it's generating around 6.5 tokens per second. And the time to first token, the time it takes to generate the first token, it's 7 seconds for the first image that you give. And then if you cache the image and you want to keep asking questions, within just 1.5 seconds, you will start generating the new tokens. All right, so here we see a very high-level overview of what's Lava, how it works. So we have first the vision encoder that it's going to take the input image and extract the features from the image. And it's going to encode these features in a language that the LLM can understand. Together with the input prompt, the the LLM will start generating an output with context of the image and the question that was given to the system. But not only that, in this demo, we have also integrated the EIQ GenAI flow technology. So this means you can trigger the system with a wake word engine and you say, hey, NXP, and it will start listening to the question that you want to ask. And then it's going to process the image together with the input prompt and generate a response out of the image. So once the response is generated, the system will synthesize the text into speech, and this will result in a very seamless interaction with the system. So the user can very easily interact with the system, ask a question, and get an output with speech. So we are very excited of this technology and this implementation. We think it's going to revolutionize what we have in the industry. And we know it's going to be a very solid reference design for our customers in the near future. So here we can see a small video of this running on the i.MX A10 Plus Freedom Board. Again, what you are seeing here is fully accelerated at the edge. There is no connection to the cloud. So we are selecting an image and we are asking the system to tell us if there is water on the floor. This image is very challenging even for the humans. It's hard to see the water, but we see that the lava model, it's capable of detecting the water, and it's telling us, yes, there is water on the floor, so it might be a spill or a leak, and it needs attention to prevent any potential damage. So we can think of this kind of applications in the industry where we cannot afford, or we cannot put a lot of sensors in the floor, and with just one picture we can ask the system to describe what's going on, and we can get a very accurate response from this. And finally, I want to also share a little bit of what we have with other models. So here we are showing Llama 2, fully accelerated with ADA2 NPU. It has 7 billion parameters, and we are getting a performance of around 17 tokens per second with a time to first token of only 1.25 seconds. So very fast responses. And this, together with RAG and other tools from EIQ GenAI Flow, we can start building a lot of new, very smart, intelligent solutions that run privately, secured, and efficiently at the edge. So last but not least, I want to invite you all to go and look at the Computex 2025 NXP keynote, where Jens Hinrichsen, Executive VP from NXP, talks about what's going on with GenAI at the edge in NXP, but mostly about Agentic AI, which we think it's the next step going forward. And what we have presented here, it's the base for you to start building Agentic AI solutions at the edge. So the summary of this very brief presentation, trying to cover a lot of topics and technologies from NXP, is that NXP is definitely transforming intelligent systems with generative AI at the edge. We utilize powerful NPUs like Neutron and ADA2, and of course, these are available for our customers. And we also offer very modular frameworks such as EIQ GenAI Flow to allow our customers to easily start building and creating smart, intelligent solutions. The key benefits, we think it's that we can enable real-time, efficient, and secure applications with AI that run on edge devices. And this will enhance our user experiences across a lot of diverse applications. NXP is committed to shaping the future of smart connected devices, and we are driving the evolution of application-ready AI at the edge. So thanks, everyone. I know it was a lot of information, trying to cover a lot in just 25 minutes, but hopefully it gives you a perspective of what NXP is doing with GenAI currently. And thanks, everyone.
Thanks a lot, Alberto. Your talk was really comprehensively explaining all the NXP solution to bring GenAI at the edge. Congratulations. I mean, NXP is doing a lot of fantastic work. We're running out of time. Maybe a very, very quick question from my side is, generative AI and large language models are subject of deep quantization. There are also approaches 1-bit LLM and the like. Do you think your solutions are ready for such extreme quantized models?
Yeah, well, definitely, I don't think we are ready for 1-bit quantization at this moment for this kind of applications, but we are utilizing for LLMs 4-bits quantization, and we know from our tests that these use cases that we have shown are ready for creating very robust applications. So yeah, I mean, it's all this is very new. There are a lot of new methods out there to be able to optimize these big models. I know in the future we are going to keep improving this. This is something that is moving forward very quickly. But for now, we are very happy to see that with 4-bits quantization, we can shrink these big models and fit them into these discrete NPUs and allow everyone to start building applications that are very private and still leverage all these GenAI technologies. So for vision encoders like Clip, we utilize 8 bits. We've seen that that gives the best accuracy with this type of models. But LLMs, definitely, we are sticking with 4 bits for now.
That's great, Alberto. Thanks a lot. It was a fantastic presentation. Congratulations. Please, if you have time, there have been some questions in the chat, in the live chat. Maybe you could try to address some of those. And thanks again for contributing to the agenda of today. Thank you.
Thank you, Danilo.
And I hope, Alberto, you will bring in Milan your demos as well.
Hopefully, yeah, sure. Thanks, Danilo. See you.
Thank you. Bye. Hello, Arniban. Good to see you. Arniban from Vipro Limited. And thanks to be with us, Arniban, and to contribute to today, to the third forum of today. I think you are going to speak about industry applications and deployments of GenAI at the edge. So whenever you feel ready to share your presentation, please do so, and the floor is yours.
Is it visible? Thank you so much, Danilo. Is my presentation visible?
Yes, it is.
Oh, okay, thank you so much. Yeah, thank you, Danilo. So today, so my name is Anirban, and I am representing Vipro Limited today to talk about some of the real-world deployment and industry applications that we are seeing. This is the agenda for my presentation. So some background on where we come from. What is the AGI relevance that we are seeing?
Sorry, Anirban,
Yeah,
we don't,
yeah.
I think you are maybe, it's another presentation you're showing because we just see your tile slide right now. I don't know exactly. If you want, try again. Because I think it's just the one that you have uploaded previously, but you're not sharing your screen.
Okay. Let me share that. Okay. Is it visible now?
Let me see. No, I think it's still the other one. I think you, or maybe now. Let's see. Is that the one? And then you just go full screen.
Table of content.
Yeah, table
right?
of content. Yeah. Now you just need to go to full screen because we just
Okay,
see all
sure.
the slides on the left. And then I'll let you take it over.
I've gone to full screen. Is it?
No, it's not. We are still seeing everything on the left to all your
Visible?
slides.
now?
No. Are you using different screens maybe? Or when you just go to slideshow?
Okay, let me try. Okay, let me share again. Then.
Yes.
Is it visible in full screen now?
No, it's not visible on full screen. If not, yeah, we just have to go that way. Like, and if you just go and take slideshow, that it's showing your whole screen.
Continue, yeah.
Right, Danilo, you can also see that, right? It's not in full screen mode. He's just...
I see, no, not in full screen. No.
Okay.
No. Any technical difficulty, Arniban?
Yeah, if not, yeah, we have to go that way, but it's not really what we want, but it's okay.
I'm sharing in full screen, but not sure, yeah. So
maybe you have multiple screens?
Or maybe you can share the presentation that I uploaded.
Yeah, I can share that one, but that
no,
is
I
the
removed
one.
that actually. Without the video, it's fine. I think we will continue
Okay,
with that.
then we go with this one. Okay, can you move forward here in that slide and then I'll...
Yeah, you can go ahead to the next slide.
Okay, so you want me to... Okay, I'll just follow you then.
Yeah. Yeah, so this is the agenda, and then some background on our team. So for those who are not aware, so Vipro is a leading global information technology consulting and software development company. We are present in more than 167 countries, and we focus on different areas, including AI and cloud computing and data analytics, for example. So I come from a background of embedded development, and currently for the last 5 years working on AI. And I would like to acknowledge the bigger team behind this as well. Yeah, we can go to the next slide. Thank you. So to talk about the use cases, so what we see are different trends in AI. So there are advancements in the generative AI models with lot of multimodal AI models coming in, and these models are driving new use cases as well as they are enabling improvements in the older implementation methods. A lot of the implementation for multimodal AI happens on the cloud, but there are certain concerns with that in terms of mainly the data privacy part of it, where people may not be ready to share all their information to the cloud, as well as the need for the availability of a high bandwidth network. So in some use cases, it is beneficial to have the inferencing done in an offline mode without a dedicated network connectivity. So in terms of looking at embedded devices, we looked at some of the different devices, and we saw that like the printers and scanners is one category where there may be a lot of applications of multimodal AI. Today, the printers and scanners that we see are mostly passive. They don't basically process the content themselves. They struggle with a lot of inconsistent formats and layouts, and basically these formats are all unstructured. A lot of the documents come in multilingual formats, especially in enterprise context, and with traditional rule-based approaches and even traditional deep learning techniques, there is very limited reformatting support which is available. So with the coming of multimodal AI, basically these passive endpoints can become more intelligent, and they can help in basically changing these unstructured formats into a more structured format. Uh, they have the power to translate the content from one language to other, and they have this special ability to understand both image and the text. We can go to the next slide. Yeah. So we took one use case, mostly on the document understanding part of it. So a lot of multimodal AI models are available even in the open source. For example, we have the Quen 2.5 VL, which is a very popular model. It is capable of handling text, images, and even other modalities. We have very special models like Layout LM V3 from Microsoft, which is basically trained for document understanding. Then there are other popular models like Donut and TATR from Microsoft for table understanding. And these are the multimodal series of models, whereas we have another series more from like the diffusion models. So we have a model from Flux. So they are very creative in generating new content. We can go to the next slide. This is our solution approach, that how on the printers and scanners, basically, we can bring in these multimodal AI models. So we have this input image or PDF formats, as well as we may have an user input that may be in the form of a prompt, or it can be by voice directions. So once this is acquired, we do some conversion. Maybe we convert PDF to image. Then we do a lot of pre-processing tasks, like we do resolution conversion, we do page segmentation, noise reduction, and so on. And then pretty much we can use the visual language models directly. For optimized inference, we can do quantization, and without much supervision, the VLMs are capable of interpreting the content, identifying key elements, and then restructuring the layouts. They are also capable of generating in the format that we desire. And then we have some post-processing activities where we clean up, prepare in the format that we desire, basically. The interesting part of this is there is, without even doing a lot of fine tuning of the base foundation models, we can get quite decent results. So primarily in our implementation, we have used two models. So one is the Quen 2.5 VL model. It excels in handling complex visual inputs, including images of different sizes and so on, while still maintaining a good linguistic performance. This model, so we have tried with 3 billion parameter, 7 billion parameter, and so on. And the configuration that we used had a GPU RAM of 16 GB, basically. On the other hand, we have also used the flux diffusion model. This has a hybrid architecture of both multimodal and parallel diffusion transformer blocks. and it had a size of around 12 billion parameters. So this also needs VRAM of around 24 GB. We can go to the next slide. So here we have primarily two use cases. One is on extracting the tabular data and reformatting to the graphs. So we can import a PDF document which has tables and other textual content. So the VLMs are quite skilled to extract the table information, and then once we have the tabular data, we can convert it into a different representation, say a pie chart or a bar chart, and then we can override, say, the tabular data with this information. So a lot of these creative things can be done with the documents. The next use case is more on image generation and modification. So basically, we were thinking about greeting cards use case. So with a textual prompt, we can create a greeting card from the model, and then we can do incremental modification text steps by prompting the model. So, for example, here uh, the greeting card says Happy New Year 2023, and then with a proper text prompt, we can modify the year to 2025. So, some of these modifications are done very simply. Then, in the third step, we wanted to change the outer boundary of the image. So, we were able to do it with a simple prompt to the model. We can go to the next slide. Yeah. This is another use case where we do the text correction, which I already discussed. Then coming to other use cases, so what we have seen is in a printer scanner use case, um, automatically we can understand the scanned documents and then classify them into specific categories. Uh, so this is really intelligent. So in an enterprise context, it really helps that it can also trigger a notification that this document is intended for this group of people. Then we have multilingual content handling ability, and these models can easily translate between different languages, and this is very helpful in typical enterprises. Another use case may be like adapting the layout for visually impaired users by increasing the font size, contrast, and simplifying the design. Then in a scanner use case, we can say have some defects in the text, and all of those gaps can be automatically filled in by the model, and error correction can be done automatically. We have seen other use cases like when it comes to giving a print from a web page, like a lot of these advertisements and other content comes in. So all of that can be automatically detected by the AI model and removed. Yeah, we can go to the next slide. Yeah. Yeah, unfortunately, I think this video will not run, but basically we were showing the table extraction. This is the text correction part of it. Yeah, you can go to the next slide. This is about changing the borders. And this is about changing the color of the bird by just a simple prompt to the model. It is able to update the bird color. Yeah, you can go to the next slide. Yeah. So this is some of the deployment aspects what we considered. So the aim is to deploy it on the edge and the device, like we discussed. But these models still need considerable resources to run. So first of all, we took a lot of steps in optimizing it. One step was basically downscaling the image. So during the pre-processing step, we downscale the image by reducing the resolution significantly so that it improves the image processing performance efficiency with some loss of accuracy. Then these VLM models are very good in object localization and grounding. So some of the tasks such as accurately locating the objects within the images using bounding boxes and point coordinates. So all of these can be done automatically for the VLMs, and as an application developer, we don't need to set up some complicated pipeline to do this. So we use the power of the VLMs, which are inbuilt. In terms of model quantization, we quantize the 7 billion parameter model using a 4-bit quantization technique, and we use the GGUF format for the model. GGUF is a more efficient and flexible way of storing and using the models for inference, and is designed to run well on consumer-grade computer hardware. In terms of the diffusion model, we did a lot of hyperparameter optimization. So there are certain parameters for the diffusion model like K-sampler and scheduler, and these can be tweaked for better performance by enabling better control of the sampling process, how the image gets generated, and by fine-tuning the sampling algorithms and parameters, we could do a balance between the accuracy as well as the performance. And last but not the least, we utilize the optimized library for NVIDIA for the GPU to optimize the performance on the GPU. So overall, like the deployment configuration was based on an x86 based processor and NVIDIA T4 GPU with a memory of around 16 GB. All the mentioned steps that we took helped in reducing both the inference time and the memory footprint for deployment on typical printer or a companion computer SoCs. So also the point of view that we have is it may still take time to deploy such kind of models directly on the printer, but we also have the companion devices to the printer like the AI PC or the smartphone, which themselves are quite capable. So some of these things can be orchestrated between both, and some things may also be done on the cloud. Yeah, we can go to the next slide. Yeah. So these are some of the challenges that still remain in terms of large document handling. We need to do a lot of segmentation tasks and batch processing to manage the memory load. Then though we did not really do a fine tuning of these base models, but for the optimum accuracy, we would need to do fine tuning per the use case, and that will help us in maintaining the performance. When it comes to embedded deployment, we have to keep in mind the thermal and the power constraints using efficient scheduling and hardware acceleration to minimize the power consumption. And last but not the least, the compute requirements are still high, but as the SoCs develop and we also get better methods of optimization, I think the deployment on the target lower cost devices would be a reality. We can go to the next slide. So these are some of the conclusions and future directions. So multimodal AI models are a transformative advancement especially if we look at document reformatting tasks in printers. And by deploying such models directly either on the device or on a companion device, we can offer customers much better and smarter printing and scanning solutions. Multiple innovative use cases can be accomplished by using these models, and this approach will set the stage for a new era of intelligent edge printing where both the content understanding and the reformatting can happen seamlessly at or near the point of output. Yeah, so I think with this we come to the end of the presentation. Yeah, and I would be happy to take some questions.
Thanks, Arniban, and yeah, your presentation was smooth, and maybe we missed your video. I don't know if you could find a way to share links
Yeah,
to the video later on so that we can enjoy your demonstration.
sure.
Can you quickly comment about what the demo were about?
Sorry, can you repeat your question?
About what your demos were about?
Oh, okay. Yeah.
What was
Yeah,
the
the
content
demo,
of the video?
correct. The demos were about some very simple examples. For example, from a document, like we can do a table extraction, right? So if you think of earlier times, right, we would have to use some very specific template-based approach for doing this extraction, or we would have to train a deep learning model using a lot of data, right? But with these visual language models, the advantage is that a lot of the knowledge for these kind of tasks are already inbuilt in those foundation models. So, and they realize both the imaging context as well as the prompts that the user gives, right? So it can relate. So when I say that, okay, you extract this table and just output it into some CSV format. So the model itself has that capability to do it. So this really would shorten the development time for application developers, and I think that is one of the key areas to look forward to.
And Arniban,
And
and a curiosity. Yeah, thanks, Arniban. A curiosity also from a business perspective. How do you consider about using a foundational model for a solution that you sell in the market? After all, the foundational model, I mean, you adopt, but maybe someone else prepared, trained with lots of data, and then you are trying to exploit, for example, for the purposes that you spoke about, and how do you manage such a solution which depend from foundational model? Is something that you consider viable, reliable, or do you see any cons about that?
Yeah, so I think people have concerns on the foundational model, like what kind of data sets that it has been trained on, and so on. So I think we should look at it use case by use case. I think the power comes from the data for the AI, and just using the foundational models may not be appropriate for any commercial solution. So we really need to fine tune the data with whatever contextual data belongs to the enterprise, right? And ultimately the model may still hallucinate, right, at the end of the day. And so we need to build in a lot of guardrails. so that if it really does, then it should have an exit path and it should give something which is more logical, right? So I think a lot of the work with AI will be with how you write the prompts, how you basically experiment with it, how you see what it is doing, and building some checks on top of it, right? And still, it would be a kind of a fuzzy system, meaning you can never predict that it would repeat the response every time, right? But basically, it still gives a benefit in certain use cases. I think that is the balance we need to draw, like where it can be applied and where it cannot be applied. So
And I like it, you mentioned that this technology can help, for example, visual impaired people. So you made me think that this great technology can help to create new services and products and application, but also serve for the needs of people with less abilities and which can really enjoy the capability of GenAI in providing machine interaction at the next level. So thanks to underline also this possibility.
absolutely,
Okay,
yeah.
very
Thank you
good.
so much. Yeah.
Very good, Arniban. It was great to have you today, and now it's time
Thank you
to
so much.
move to
Yeah.
Pete. Thanks, Arniban. Great to see you, Pete. I see you were very well.
Yes, thank you, Danilo. Great to see you too.
Really glad, and you are in great shape. And before I let you to speak, I would like to, since there is a huge number of people connected, it's my particular pleasure, and I'm not formal, to see Pete, because Pete work was seminal in building this community. He started the first TinyML summit in 2019 with Evgeny, and doing these things for the first time is the challenge, capital letters. Yeah, I still remember, Pete, you doing a great job in creating what we today we are still on, and it continue to expand. So I leave you the floor, Pete. The time is yours, and yeah, we need to understand why it's useful, and have your point of view. Thanks, Pete.
Well, and if it's useful.
I'm sure it will. I'm
Yes.
sure it will.
No, thanks so much, Danilo. And Danilo's being modest. He's been a massive driving force behind this whole movement for the last ever since God, however long it was.
Well,
So,
it was, if we count 2018, we are 7 years, 7 years. Wow. Yeah. And I still remember fantastic discussions with you when TinyML was really at the beginning. Yeah. By the way, the floor is yours.
Perfect. So I'm sharing my slides, but that means I have to quit Chrome because I'm on a new laptop and log back in. So I will disappear briefly and then be right back.
Yeah, we'll wait you, Pete.
Okay,
Yeah.
sure. We'll wait for you.
Just a quick pause to drink a glass of water, and we will restart soon with the Pete Warden from Useful Sensors. And it's very interesting to have Pete speaking about the opportunity of GenAI and coupled with sensors. Sensors generates data, and then GenAI should make a new meaning out of this. Oh, you are back. Good.
I am, and I get to use my a joke that my wife groans at. She's heard it so often, but at Google used to say that it's going to be easier to solve AI than AV. So I think this is this is another instance. And yeah, let me start sharing my slides. Just a second. Here we go. Hopefully you can see that.
Yeah.
So awesome. Okay, thanks, Danilo. Thanks, everyone. So what I'm going to be talking about today is really trying to dive into not so much why, but sort of what incarnations of GenAI are actually useful at the edge. And Danilo has gone over a lot of this already, so I won't linger too long. But, I'm talking about this because I've spent a long time working on trying to get some of the cutting edge stuff that's happening at AI down to edge devices. And that has been really interesting. And it's only really in the last couple of years that GenAI has, become a thing. So one of the obvious questions is, okay, how does GenAI fit into this world of edge devices? And one of the first questions is, we've got all of these GenAI products and models running in the cloud. People seem to be using them. I use them for, helping summarize things, creating images, all sorts of things like that. So is it even interesting to talk about using these things at the edge when people seem quite happy using them on a cloud-based service? One of the first points I want to kind of call out is it's amazing how much compute there is at the edge. I tried to do some fairly conservative math, back of the envelope stuff, to figure out how much compute there is out there at the embedded level. And this is just microcontrollers, not even including phones and other devices like that. And my best estimate was that there's about twice as much compute in all of those MCUs as there is in all of the GPUs in the world. And if you want to follow along with this too, I've got these slides up at the link down in the bottom right corner. So don't worry about trying to take screenshots or scroll down these links. You can, if you grab that link, you should be good. And you're here on this Edge AI conference, so you're probably kind of aware of the advantages of actually getting lower latency, more privacy, and the fact that by not relying on connectivity, things that you run on the edge can work anywhere in the world. One of the things I've struggled with when looking at GenAI is, as an engineer, it doesn't make all that much sense as a category. Coming at it from the model building side, Gen AI models don't look very different from models that don't generate new content, but use transformers. So from the implementation and the system and the ML kind of engineering side, what really made a massive difference was transformers coming along, and the whole BERT, attention is all you need, kind of revolution that happened. But the result of that has been that a whole bunch of generative use cases have emerged that weren't possible before, or at least you weren't able to use them very effectively for doing actual generation of novel content. But if you actually look back at the history of all of this ML stuff, we've had auto-suggest for a long time. Is that generative AI? We've been doing photo enhancements for years. Is that generative AI? And even at the one area that I'm spending a lot of time on at the moment is around voice interfaces. And text to speech is a generative use case, but speech to text isn't, by the usual definitions, which kind of feels odd. But there's a reason that it's become a category, because it does kind of draw a line around a lot of really new and interesting applications that didn't used to be really possible before. So basically that's me putting a lot of caveats around GenAI as a term that we're using to kind of analyze this stuff, because it makes sense when you're just looking at the outputs, but when you're actually looking at how these things are implemented, whether or not the model is generating novel content or it's just trying to extract information that's in the inputs and use that as the outputs, doesn't really make much difference to the models themselves. GenAI is something that's definitely in our eyes as the beholder, not something that's fundamental about these models. So kind of, talking about transformers, because while not all transformers are GenAI, pretty much all GenAI in the modern sense are based on transformers and attention. They are honestly a bit of a pain compared to convolutional neural networks, because they tend to be, and I realize I actually made a mistake in this first bullet here. They tend to be memory bound, which means that they're hard to accelerate. So what that means is when you have small batch sizes or batch sizes of, say, 1, the weights that you're bringing in to multiply and accumulate the activation layers against, you tend to only use those weights once before you move on. And so that means that you're fetching a lot of weights and doing comparatively little compute using each of those weights. So it's very easy to get memory bound, and that also means that these models tend to be very large users of memory, and that has a big consequence, which it means no matter how much compute you have using NPUs on your microcontroller system, you need larger than, you need at least tens of megabytes of memory, which is too large to fit in SRAM. So you end up having to use something like DRAM. So that blows your power budget, your energy budget out of the water, because even if your microcontroller's using, 5 or 10 milliwatts, DRAM generally is going to need on the order of hundreds of milliwatts. So you lose a big advantage and a big reason to use truly embedded kind of microcontrollers. But all is not lost. There's a good chance that you're going to be able to run this stuff pretty effectively on the application processor class. Basically, these days, Cortex-A, ARM Cortex-A, because those systems tend to have, easily gigabytes of DRAM. So you can actually do a lot of neat stuff using those systems, even though they're not true low power systems. At least they're on the edge. And there are some things you can do to improve the performance of transformers, and especially around the memory side, because we're effectively doing a lot of fully connected operations inside the attention blocks. You can actually split that up, effectively doing something equivalent to tiling, so you don't have to generate the whole activation all at once. It's also nice to have something that's kind of a general purpose accelerator, like the Qualcomm's H3X kind of hexagon derivative, because you can actually use general purpose programming with them. They aren't fixed function accelerators. So that means that you're able to write transformer-based approaches using those sorts of DSPs and those sorts of accelerators. The key thing is you want something where you could actually implement things like new activation functions and other stuff that was not envisaged when the hardware was originally designed. And I know a lot of hardware companies out there, because they have to design stuff like several years before it gets actually turned into silicon. A few years ago, we were still focused on convolutional networks. So they came up with fixed function accelerators that worked great for them. And they're coming out into the market now, whereas the ML world has moved on and is looking at mainly transformers, and those fixed function accelerators are no longer nearly as useful. So this is for all the hardware people out there, please try and make your NPUs generally programmable to be able to run general functions, even if it isn't particularly fast, because I'm sure there's going to be big changes over the next 2 or 3 years, building on top of transformers. The other thing that I always ask hardware people is, let me actually bypass the cache. Let me use the cache as tightly coupled memory that I control, because for CNNs and transformers, there's no data-dependent branches in there. We know exactly what data we're going to access, what memory locations for millions of cycles. And a lot of the optimization work of the inner loops of runtimes is about trying to work around the fact that the cache thinks it knows better, and trying to persuade the cache to actually load what we know we're going to need next in there too. So please let us use the cache as TCM. So one of the most interesting use cases, I think, for GenAI is about retrieving information. my kind of best guess is that, you know, maybe 80% of the Google search queries out there you can answer by an LLM, and unlike the Google search process, which requires data centers and, you know, tens of thousands of machines and storage drives working together, this can actually be done completely locally with no network connection. So there's all sorts of long-term implications for information control, and actually trying to, especially countries that want to control the information that makes it to their citizens, it's going to be a lot harder once you can have these models running with no network connection potentially and being able to answer a whole bunch of questions. But the biggest problem here is that, as we've seen, I mean, even over the last couple of weeks with the whole Grok white genocide debacle, LLMs lie. There's no good way to verify that what they're saying is actually true. And they can even be sort of made to lie deliberately. But even if you don't do that, there's a lot of issues. And the big problem is that pretty much all of the models over the last, you know, 10, 11, 12 years through the whole deep learning revolution, when you give them an out-of-domain input, an input that's kind of out of the range of things that the model's been trained on, it will confidently come up with an answer that's kind of based on nothing. And a lot of people turn to RAG, retrieval augmented generation. But what that means is you're kind of going back to almost like the Google search engine results, and then you're feeding them into a generative AI. And so that means you just have to make sure that your information retrieval system is really good. In which case, you know, the LLM is in a lot of ways just kind of polishing the prose of the answers that it's already found through the traditional, you know, database query or however you're doing it. So one of my obsessions is trying to turn natural speech into actions. And if you look at what's happening with, you know, Siri, they had a big executive shakeup. Alexa at Amazon has kind of gone through something really similar. And I think a lot of that is because we are used to interacting with these LLMs via text and getting very intelligent looking text outputs. But once you try and do that with something that's controlling your home and you say switch on a light, that's a lot harder job for the LLMs to actually figure out, because that's not really in their training data. Their training data is all about matching, you know, text inputs to text outputs, and there isn't much information about the actual real physical world. So I'm kind of hoping that we can actually make some progress on this, and this will be an important use of generative AI if you think about it as generating actions. But that's going to be a long-term process, actually figuring this out. I do think that there's still a lot of use cases for large language models on the edge doing knowledge retrieval. And the approach that I found pretty interesting working with customers is trying to essentially look up FAQs using natural language. And I think that this is particularly interesting for kind of use cases where you want to attach some knowledge to a particular location or object. So, for example, having boxes on pillars in supermarkets that you can just ask where products are, or having a little a small SoC magnetically attached to kind of an engine or a fridge or something like that, and you're actually able to ask user manual questions out of that. So I do think that there are some use cases for knowledge retrieval, but the key thing is that it really has to be a lookup of pre-vetted material from FAQs versus just kind of generating pure text. So I'm gonna sort of skip over some of the speech to intent stuff here because I want to leave a little bit of time for questions. I would encourage you to look for things like the Sesame demo of voice synthesis, because it's kind of amazing. And I really think that having natural voices is going to be something that users really grow to expect over the next year or two. And it almost becomes like an OS level feature to enable this. I've really struggled with generating other kinds of audio or images or video on the edge. Most of these use cases are around sharing things versus kind of consuming them just totally at the edge. So you really need kind of some network in there anyway. And so using the cloud doesn't seem a bad idea. I really like the idea of, again, related to speech to intent, actually generating actions and having robots do things, but it's very unclear how we'll find the data sets for that. One thing that has been coming up a bit more recently is if you think about the edge as being client-side in the browser, there are a whole bunch of really interesting things you can do there using the, often the phone SoC or the laptop or whatever it is you're running on. So I think we're going to see a lot more of that. And that is it. That is my kind of brain dump of how I see generative AI at the edge.
Thanks a lot, Pete. Really was a great opportunity to hear from you. And obviously, people put questions in the chat. So let me take the opportunity of having you here for some of these questions. Maybe some are not related to generative AI. So, Alexander asked, which area do you see has more potential for Edge AI, video, voice, 3D, radars, time series, sensors, data, or else?
So, like I mentioned,
Pete? Pete, maybe we lost you for a second.
Yeah. I do see that. Oh, are you still there?
No, please answer. The question from Alexander was, which area do you see as more potential for Edge AI, video, voice, 3D radars, or time series, sensor, data, or else?
So voice is the only one out of those I see potential for, because I think, at least according to the definitions I've seen, 3D radar and time series data doesn't like, it's not very useful to kind of generate that stuff on the edge. Video, potentially you can generate that on the edge, but it's often something that you want to share versus just consuming yourself. So voice, and especially text to speech, I think is the one that has most potential.
Thanks a lot, Pete. From Nicholas, do you believe non-volatile resistive memory will contribute to the acceleration of edge generative AI, since we need a more powerful NPU, as you commented during your speech? What's your point of view?
Yeah. So I don't know enough about NVRAM. So I don't know, for number one. I would love to see better memory technologies that better fit with transformers. So that sounds great if that works. And for number two, what degree do I believe closely coupling the model architecture with the physical memory layout? I've seen a lot of really interesting work about bringing the compute to the to memory, like in-memory compute. I haven't seen that emerge as kind of something practical on silicon that we can use for this yet, but I think it's a really interesting direction.
And last question, Pete. I would love to have you here for more time, but we have a tight agenda. State space model from George instead of transformers for embedded. That reduce the cost of attentions in your opinion?
So I haven't spent a lot of time with state space models. What I have seen is that it's still been very hard to beat transformers in terms of kind of the accuracy that you get for the amount of compute you do. But I will admit I haven't spent enough time with state space models to have a fully educated opinion on those.
That's great, Pete. First of all, thanks so much to find time and be with us today. I was really excited that you accepted to speak with us. And I know you are very active on speech, and that's great. And really would be great. You share great content, as you are doing with Moonshine, for example. With the community, which is your developments are a great asset for the community.
Oh, thank you. So, that's very kind.
Thanks so much, Pete, and have a great day.
You too. Ciao. Thanks, everyone.
I leave the floor to Ajar, to Professor Ajar Moussanif, which moderate from now on. Ciao, Ajar, the floor is yours.
Thanks, Danilo, for the handoff, and a big thank you to all the speakers we've heard from so far today. Their insights have really set the tone for what's shaping to be a transformative conversation around GenAI. And I encourage all of you to stay with us until the end, because we've got some more fantastic sessions coming up, including our next talk from a true leader in Edge AI innovation. It's my pleasure to welcome Dr. Vinesh Sukumar from Qualcomm. Qualcomm, as we know, has been leading the charge, bringing powerful, low latency and privacy-preserving intelligence directly to our devices. And he will be talking about shifting paradigms, the move of AI center of gravity to edge devices. Dr. Sukumar, the floor is yours.
Thank you, Ajar. Can you guys hear me okay?
Yeah, perfect.
Perfect. Thank you for the generous introduction. I just want to make sure is my presentation come up well as well. Perfect. Okay, awesome. So quick introduction about myself. I'm Vinesh. I lead the AI product team at Qualcomm, where I have the absolute privilege, I should say, of working with some fantastic technologists, engineers, and researchers. And then we translate blue sky vision into some exciting experiences on the edge for both consumer and for enterprises. So at Qualcomm, we strongly believe that what happens on the edge stays on the edge, using obviously the borrowed phrase. And today, I'll kind of take the next 30 minutes of your time to kind of walk through why we believe there's been a lot more significant investment on Qualcomm side and also the ecosystem side, and how there's been a shifting paradigm of moving a lot of generative AI use cases from the cloud all the way to the edge, and what is Qualcomm doing about it, and what are some of the commercial successes we have had for the last 12 months or so. So with that, let's get started. I think today's the Edge AI Foundation conversation started off with saying a big statement saying AI is changing the future, and I truly believe it is in many ways. Historically, when you look at Edge AI use cases, they were a lot more focused on perception AI, which is all about detection, classification, segmentation, image enhancements, background segmentation, anything you can think of, mostly around audio, speech, and computer vision. They're still important today, but to a large extent, I would say it's been commoditized. And I would say give or take about 18 months or so, there was a lot of shift wherein the entire industry kind of moved from perception to generative AI and looking at how could generative AI kind of enhance the next user experiences on the edge. And one such experiment that we did was at MWC 2024, give or take. We had a showcase that using text prompt, we could generate a lot of synthetic images, which at that point of time, using stable diffusion models, we were able to generate that. And now with time, obviously, in the last 12 months or so, we have deployed successfully commercially a lot of generative AI applications on premium Samsung devices, premium Oppo, Vivo, Xiaomi, Honor devices in Asia, wherein we have used large language models of multiple flavors, multiple sizes, large vision models, also working with Google on Gemini to look at productivity enhancements around writing. Could be sentence corrections, could be notification summaries, could be recommendations on how do you want to reply to a certain message, all kind of things. So that was, I guess, our first entry into how GenAI applications was commercialized on handset devices. As we transition, there's also a lot more interest in the automotive environment, especially in the infotainment space, where it was using voice as your primary interface to improve the human-to-machine interaction in such a way that conversational AI became quite more important. And this is actually a very true example, as I happen to have a 15-year-old car, and oftentimes, it breaks down. And whenever it kind of breaks down, depending upon the shape of the light, the amplitude, the frequency of the light, I need to open up my 300-page manual and then try to understand exactly what the problem statement is. And then, got to pick up my phone and then book an appointment to make sure that I don't lose, upgrading the services that's needed to get the car back on track. But all this can be completely eliminated if I happen to have a conversational AI assistant, which is largely based on a large language model as the primary hub of it, wherein you can ask for exactly what issue is with your car. It has a lot of knowledge about the environmental conditions. It has a lot of history about the car, and kind of gives you an immediate answer that this could be a potential problem statement, and also gives you the suggestions on can I book the next appointment with your car mechanic, because it also has access to my calendar. All this is completely done in about a 5-minute span based on conversational AI. And this seems to be taking a lot more traction in the consumer space, and you're going to see a lot more exciting use cases in the automotive land as well. Same thing can be done on the PC side. PC was exciting for us is because we had the opportunity to work with Microsoft and launched the first Copilot Plus in build, which happened to be April 2024 timeframe, give or take about 12 months ago. And working with the Phi model that Microsoft works on, we were able to anchor it on defining how productivity looks in PC space. It could be elements like semantic search, wherein using few characters, you can bring out the right documents of interest, right files of interest, as an example. You could look at large PowerPoints, you could look at large documents and summarize it completely based off your style and based on the intent. So we're able to get, I would say, how productivity could be, remorphed or reimagined using large language models on the PC side. Now, using that investment, we're now expanding this also to other domains like XR domains, industrial, and also networking. This is something completely new. Some of the challenges on the XR are going to be more about sustained power and being able to maintain a high amount of accuracy with small amount of models. So still in a little bit of an early research phase, but I expect we'll be transitioning this into commercial products in the next 6 to 9 months or so. Now, that being said, there's always been a question is, why transition from the cloud to the edge? What does on-device AI really help with? I'm sure, many of you folks online have already heard that it always helps with better quality of service, preserves user privacy, always have a lot of elements of personalization, wherein you're able to get the emotional intelligence of the user baked into the model to kind of give the services that you're looking for. But the most important asset, I think, is as you transition and move forward, is these devices need to have a personal knowledge graph of the user. And the personal knowledge graph of the user gets more enhanced as you have multiple experiences enabled across multiple form factors. That is, in other words, if you happen to have a Qualcomm handset or a Qualcomm glasses or a Qualcomm PC-based device, you can exchange the knowledge graphs between devices, and that serves as a powerful platform for a lot of developers, for a lot of application users to actually build on top of it. That way you can look at context preservation and also have a continuation of any kind of UX as you transition from one device to the other. And all of this can be done completely on the edge without relying a lot on the cloud. Now, that being said, what is next? There are portions that we still have to work on from a foundational investment standpoint. One is on the model size. To a large extent, these large language models are kind of coming up in multiple parameter sizes. What we found as a sweet spot is when you look at handsets, most of the use cases that are being deployed are between 1 to 10 billion parameter range. Same thing on the PC platforms, they're between 13 to 20 billion parameter range. And if you expand that to, let's say, smart glasses, it's about between 1 to 4 billion parameter range. Now, one of the most important elements when you want to deploy these large models is about memory capacity, and you want to make sure that you have enough bandwidth to be able to generate tokens of interest so that it has a decent enough conversation with the user, and obviously not to mention the accuracy is not compromised. And that needs a lot more work, I would say, in how do you quantize the models, how do you fine-tune the models, and how do you compress these weights so that some of the bounding boxes of the UX is completely maintained. On top of it, you also, as I mentioned, need to improve on accuracy. Historically, most of these models are unimodal in nature, meaning that you give a text prompt, it gives you a response. But in reality, hallucinations to a large extent can be reduced if it's multimodal in nature. It's pretty much like humans. Like, we see through our eyes and we talk through our mouth. So which means it's a combination of text and computer vision to begin with. So moving forward, most of the experiences that we're going to be launching on Snapdragon devices is all going to be multimodal in nature. And at the same time, it's also becoming quite relevant, as I mentioned before, is we want to move towards a personal element. And the only way that you could drive personalization is to have a contextual information about the user, contextual information about a conversation that has happened, and kind of give details on exactly what you're looking for. And for that to happen, you really need to support longer context. No longer you can kind of operate between 1K to 4K kind of tokens. You need to move towards 16K or 32K or even 64K kind of tokens. That is obviously going to be a little bit of a challenge because at that point of time becomes compute bound, and we need to have enough investment in what you call compute blocks to be able to handle a larger KV cache. But that's something that we're working on and trying to make sure this could be completely enabled as part of our devices that we're launching for next year. At the same time, it's also critical that, okay, fine, you're putting a lot more investment on foundational infrastructure to get things highlighted. But at the same time, the state of the models that we use for commercial deployment is also very critical. I kind of showcased you a list of models for the last, I would say, 12 to 24 months, and how they have improved with time, and how do they compare by using the traditional MMLU scores or the model intelligence index, and the reference point has been the Llama 370B. And you can see that the small language models with time are actually getting better and in fact overperforming compared to a large language model. And there are plenty such small language models. And they're coming from communities like Gemma from Google, Quen from Alibaba, or even Phi from Microsoft, Mistral flavors of models, and I'm pretty sure there are quite a few of them which are which are very locally based from different geo populations. Again, the intention is small language model quality is improving, and Qualcomm is trying to take full advantage of it. And we're trying to see if we use these small language models and we try to fine tune it to be more domain specific and also task specific, so that we can go execute to certain kind of use cases that we want to go establish. Now, that being said, we also want to kind of compare the cost factor. Now, we're not suggesting by any means that all the inferencing will be completely transitioned to the edge. There's always going to be a dependency on the cloud. But we only want to be transitioning to the cloud where there's an absolute sense. Why? Because we want to keep the cost, or what we call the inference cost per instance, as small as possible. When you look at most of the common models, again, these are published numbers that we took from November 2024 artificial analysis survey, wherein the cost of these models were quite different. I'm pretty sure even today they might be even lower than this, or even higher. Numbers keep changing on a regular basis. They're between $2.50 to $4.50 to the majority, or I should say the tier one based models, which are based in the US, and they're quite expensive, and it becomes very difficult to scale. And our expectation is, for scalability, it's most important if you transition towards the edge. Then some of the most simple use cases can be completely resolved, and certain use cases where edge is not able to handle it at that point of time, transition towards the cloud. That way, the overall cost factor can be minimized from a user perspective. Also, now, how do you do this transition between the edge and the cloud? As I mentioned before, is there are going to be use cases wherein we always position Qualcomm-based devices to do inference. But there are going to be instances where you want to push it to the cloud. And pushing to the cloud is how we look at hybrid AI. Hybrid AI could come in many ways. In fact, some of them are already running today, is wherein you're defining the use case to be predefined, meaning for certain use cases, for example, you want to know something about astronomy. In that case, if the physical device, if physical model on the device is not able to handle it, for this category or for this classifier of astronomy, you want to push that kind of inference towards the cloud. But if you happen to have a certain amount of, let's say, a chat-based discussions with the user, at some point of time, if the model on the edge is not able to handle the user queries, that router at that point of time decides that I just cannot help the user, but it bakes in all the contextual information it has had with the user, transitions to the cloud, and make sure that it is seamless. That's what is going to be the next phase of enablement, making sure that the router that's set up on the device to do these hybrid kind of conversations is difficult, because it cannot be static in nature, it has to be dynamic in nature, and it needs to shift just not to one cloud, but to multiple clouds. So that's what we are focused on, but we believe that moving forward, we can always rely on hybrid AI, and we push towards hybrid AI only on use cases that cannot be completely solved on the edge. What are some of the interesting use cases that we have established? I kind of gave a quick teaser before, but when you look at the entire span across automotive, across AR, VR markets, across PC markets, it has kind of spread across the productivity domain. It has spread into content creation, content summarization, and they look at many elements like text creation and summarization. We've looked at AI assistance, live translation, code generation. All this is happening today. It is not like a wish list, but they've actually been deployed on the edge. And we expect, we're going to have a lot more use cases established as we transition from, I would say, a generative AI space to an agentic space. You're going to see a lot more traction and how edge AI use cases evolve in the generative AI space. Now, as we touched on agentic AI, one of the biggest challenges on agentic AI is how do you look at AI moving forward? So the expectation is you want to understand the intent of the user, you want to interpret it and take action. And this is how we move towards an agentic flows. Now, agentic flows, by definition, is in a position to take inputs from multiple modalities. Either could be your text that you want to use a keypad to write, or you could use your voice, which is now being very popular. So the voice, when you kind of give a command or put in a request, acts as your primary interface wherein it translates your speech into text. And the very first model that's available tries to understand what exactly is the user looking for. Once you understand what the user is looking for, then you try to translate into a specific set of actions. This is what we call as as the AI being next UI. These actions could be booking a specific slot in your calendar, or could account for even compound actions. Compound actions is very difficult to accomplish, but this is something that Qualcomm is hugely focused on moving forward. Is compound action in this case be is I can give a task to my assistant on a device, suggesting is I like to travel to Paris in my next vacation. The agent on my device needs to understand when is my next vacation. It needs to understand my preference of which airline I like to travel. It needs to understand my preference of which hotel to book. It needs to understand the preference of when do I need to come back to attend important meetings, back to my office. So these are multiple compound actions, and having access to all this information is quite difficult and challenging. But this is where we're kind of pushing our investment moving forward is, can these agents move away from simple actions to compound actions? And if you're able to accomplish it, then you're able to create a next generation of UX, which is quite meaningful for the user. And this is how we're trying to establish it. Now, how do we go approach and solve it? The very first thing is you want to make sure that the interface that you have from the user is quite clean and set up. In other words, your voice UI, if that's your primary interface, has a pretty good ASR and LLM model that's able to translate the speech to text. The text goes into an LLM, in this case, a classifier. And it's, I would say, between a 3 to 7 billion range kind of a model, which is able to classify the task that the user is looking for. Once you understand it, it needs to take actions. A simple action could be as composing an email. By definition, you have a task-specific SLMs that goes and does a specific action to compose an email. But if it has a compound set of actions based on the example I provided, then there's a series of SLMs that needs to be activated to get it done. And these SLMs could be multimodal in nature, or could be any other modality. And if the device is not able to complete those actions, at that point of time, the expectation is it goes and does an element of conversation with the cloud to get things done. So these are a certain set of use cases, which is what we are trying to push for, and kind of comes in many categories. It could be function calling, as an example, wherein you want to do these bookings or entertainment or navigation, any kind of those setups. Or it can also be looking at the next evolution of what we call as action space. Is depending upon a certain request from the user, you want to take a certain action. But again, the elements of all of these agentic flows is based on the foundation that we've just set up. Now, one of the advantages that we have for Qualcomm is, we have, a use case that's established across multiple OS. We work on the Windows environment space, on the Linux environment space, on the Android, the Ubuntu, RTOS like Zephyr, and many other stuff. And the most important element for us is, how do you really scale across multiple edge devices spread across multiple OS? And the only way we're able to accomplish that is using a common software stack, which means that you're able to develop once and then deploy across anything. And that's how we have the Qualcomm AI stack that we advertise to all the developers and third-party users, give or take about 3+ years ago. And using that foundation, we have kind of developed a set of tools to really make sure from development to deployment cycle, we can shrink it down as much as possible. Now, how does all this orchestration and the Qualcomm AI stack all work together? Now, when it comes to the hardware element, we have 3 primary hardware blocks. One block is or I should say the CPU and the GPU, kind of combine them into general purpose compute machines. These blocks are good for running a lot of inference on the edge, but it really depends on the use case. If you're looking for a lot of planning or prediction tasks, which to a large extent need better quality of service or instant latency. An example could be is if you happen to have a lot of tabular data in an Excel document and you want to look at recommended charts that you want to create, and that can be done on a CPU, because this is a small compute workload. You want instantaneous recommendations that you need to provide to the user completely done on a CPU. Coming to a GPU, a lot of reconstruction, rendering, or gaming kind of workloads. that is kind of built within the game engine itself, you want to be running on the GPU. You don't want to be transitioning that between a domain-specific or another general-purpose compute machine because it impacts your frame rate. Now, it comes to the NPU. This is a domain-specific AI engine that Qualcomm has invested in. We go in by the name Hexagon NPU, and this specific Hexagon NPU is built for highest performance as lower power. And the expectation is if you want to look at more sustained kind of use cases, could be it's a human-to-human interaction. The human-to-human interaction could be like background segmentation or any kind of live translation or any kind of background segmentation with image quality enhancements. All of that could be completely run on Hexagon NPU. Even today, plenty of large vision models are completely run on NPU because for large vision models, it's very critical that the time it takes to generate a synthetic image, be a 512 by 512 or 1K, depending on the prompt, needs to be as fast as possible because you don't want to impact the user experience. And that's completely driven by Hexagon NPU. So we continue to make investments both in the general purpose compute machines and also in dedicated AI engines because it wants to service different kind of use cases so that the UX is not compromised in the end. We briefly touched on the AI stack before. As I mentioned before, to really drive for scalability, our expectation at Qualcomm is we need to have one Qualcomm AI stack. And our stack is, I would say, give or take, built into 4 important blocks. The first one is at the framework level. We are in a position to ingest graphs from multiple frameworks. It could be a TensorFlow, could be PyTorch, could be Onyx, could be Keras, JAX, and many more. So we have no issues on graphs that we're able to ingest. Second thing is on a runtime perspective. On a runtime perspective, we have, I would say, 2 opportunities. One is scalability, another one is performance. Historically, when you look at scalability, we used to work with, and we continue to work with Google for light RT support. With Windows, we recently launched the Windows ML in build a couple of weeks ago, then with Meta on Executive Torch. Now, this is for scale for developers wherein they want to have better time to market from portability standpoint. Other one is more about performance. Performance is where we come up with our own runtime. In this case, it's called the Qualcomm AI Engine Direct or Qualcomm Neural Processing SDK, wherein if you want to look at a certain highest performance, either for vision or for linguistics or test kind of use cases, it can be completely done. Now, for the last, I would say, give or take 12 months or so, we've been working with a lot of OS vendors to make sure both the scalable portion and the performance version kind of come together through what we call as an extension provider, so that you don't lose performance in the scalability portion. And as such, most of these what we call scalable runtimes like Light RT and Onyx runtime also have an extension provider that's mapped to Qualcomm runtimes to make deployment much more easier. And last but not the least, you have pretty specific developer libraries and services, which many developers can use for any kind of fast Fourier transforms, linear algebra, or if they'd like to look at profiling, between 2 points in the graph or between op to op, this can be completely established. So, and our Qualcomm Agentic AI orchestration that we had presented, give or take, in December of last year, now runs on top of Qualcomm AI stack. And the expectation is we now provide the opportunity to developers to build apps using our agentic flow. As I mentioned, the intention is to start off with the adapters on-device models on the edge, and if the edge is not able to service a certain user ask, and at that point of time, we transition towards the cloud. At this point of time, most of the agentic flows that we've established and exposed to all the developers is based off function calling, where we've integrated with a lot of enterprise vendors in the navigation space, in the entertainment space, in the music space, in the reservation space, and we'll kind of expand that portfolio with time. And very soon, we'll kind of also expand that into action space as well. Last but not the least is also want to take the opportunity to introduce Qualcomm AI Hub. Qualcomm AI Hub was introduced to all our developer community, I would say March, give or take, of last year, wherein we provided the opportunity to developers to see if they could pick any model, or if they want to bring in their own data, they can completely quantize it across either Windows or Linux or Android subsystem They could pick a target of choice. They could then develop the model. They could test it, and they could deploy it. The greatest advantage that you have from Qualcomm AI Hub, you also have reference devices that's hosted on a Qualcomm developer cloud. So in other case, you don't really need a physical device to actually run these models. And once you run these models, you also get a lot of performance numbers. Could be in terms of latency, could be in terms of bandwidth, could be in terms of tokens per second, whatever is the KPI of interest. It gives you a good judgment on what is the expected performance. So once you happen to have a good read for it, then deployment becomes much more easier. We have 100 plus models which are available in Qualcomm AI Hub, and these numbers continue to scale on a daily basis. So, as I mentioned, we introduced Qualcomm AI Hub, give or take, about March of last year. In about 12 months or so, we have about 1,500 companies using Qualcomm AI Hub, quite a few of them which are quite popular, OEMs, ISVs, a lot of developers. We also have a lot of strong engagement with model makers. The model makers include public models and even private models. Public models coming from Meta, from Microsoft, and some private models coming from startups like Mistral, Preferred Networks, a quite popular model creator in the Japan ecosystem. So this foundation actually provides the access to the developers to bring their own data or bring their own model, and you can run it on any Qualcomm-based devices. And as I mentioned before, we have more than 100 plus models, and please do try it, and we're happy to get some feedback on that. And finally, we want to end the conversation by suggesting that we are kind of expanding a portfolio of how inference is done. For us, inference always starts on device for many advantages that I mentioned before. But there's also going to be instances wherein if the edge is not able to service it, then we want to go on to the next level. The next level would be the connected set of devices. In other words, if I'm doing an inference on a handset, if the handset is not intelligent enough to produce a response, then it gets connected to a PC subsystem, does the same thing. So within a Snapdragon garden of products, we start off with an on-device deployment. And then even if that garden of Snapdragon devices is not able to help provide or support a user query, then we transition to what we call as the next level of enablement, which is on-prem edge or the network edge. At that point of time, here you have a much larger model, and then it kind of continues the conversation on what the user is looking for to support that. Again, keeping privacy in perspective. If the on-prem edge or the network edge is not able to service that request, then it takes the same amount of information that it had from the user and then goes towards a central cloud to get the same conversation going. Now, obviously, there's going to be a certain amount of impact, the latency, but our expectation is we want to preserve user privacy and security as much as possible and scale with time only and only if that's necessary. That's how we kind of scale our GenAI deployment for both enterprise and for consumers. With that, thank you for the opportunity, and hopefully we have some time for questions.
Yeah, thank you. Thank you so much, Finish, for the insightful and forward-looking talk. Well, it's clear that the move to on-device isn't just a technological or technical evolution. It's a shift in how we build and experience intelligence in the real world. So I'd love to take this conversation a bit further with a few questions from my side. I can't see any questions. Yeah, maybe one question from the audience. Question from Samnat Mukherjee. What is way to start Qualcomm AI Hub, and what are the prerequisites?
There's actually no prerequisites. Actually, you can go to Qualcomm AI Hub /qualcomm.com, if I remember correct. I'm sure I'm murdering the HTTP address, but if you do a search on Qualcomm AI Hub, it gets you straight to that link, and there it gives you a complete portfolio of models that's available, and it kind of gives you a detailed expectation on how can you develop interesting applications based on that. And we also have an active developer community where there's questions that you can ask, and they reply back to you as soon as possible.
Thank you, Finish. One question from my side. You mentioned that Qualcomm promotes train in the cloud, run on device model. But what are NVIDIA's solutions or strategies for enabling on-device learning, like at the edge? Not only inference, but training on the edge and all that kind of stuff.
A great question. So I didn't touch on-device learning in this session, but at Qualcomm, we're putting a lot of emphasis on personalization. And personalization, by definition, cannot be static in nature. It has to be dynamic in nature. So for dynamic in nature, you need to know a lot more about user perspectives. User perspectives could be either identified by user as a supervised learning, or it's completely independent of what you call a semi-supervised learning based off some kind of feedback from the user. You're able to label the data and get things done. So once you're able to get that data that's identified by the user, then we have the infrastructure that's already available, wherein if you happen to have a device that's plugged into a socket, so at that point of time, you really don't care about battery life if it's a portable device. And then using, let's say, a PyTorch as an example or LibTorch as an example, you take the physical weights of the model, and then based on the data, you continue to fine tune a device to get things done. And now we're obviously trying to improve on things depending on the time, the power, and efficiency kind of stuff that will continue to happen. But that's already being set up both for vision-based use cases and also for textual-based use cases. Now, if you want to do native training on device to begin with, that's a completely different story. We would probably recommend that to train outside the device itself, probably on a cloud server, and then bring the trained model on device where you can continue to fine-tune what we call as on-device learning.
Okay, thank you, Vinesh. My last question, how do you see the role of open source models and developer tools evolving in the edge AI ecosystem, especially in accelerating innovation, beyond large tech companies?
I think it's a great asset to have. In Qualcomm, we don't really create models. We're not model creators. We actually work with a lot of open source model vendors, and open source models have shown a tremendous amount of success. You can see that from the versions of Gemma, the versions of Phi, the versions of Llama, the versions of Quen. And they continue to kind of drive a lot of innovations. And with the latest paper on DeepSeek, some of the elements that we knew about how reasoning works, how a fusion with MHA is all being set up, was all a good learning for us. So that when we actually want to do a lot of inference, it is just not about instruction-based systems, but also reasoning-based systems, right? And I think all that was established because of models being open sourced. So I totally suspect you're going to see a lot more innovation if there is open source. Now, obviously, there are going to be certain vendors who continue to be closed source. I'm pretty sure they have valid reasons for it. But at Qualcomm, we definitely partner with both, and we try to make sure developer gets the best access of all of them.
Thank you very much, Vinesh, for this great presentation. And now it's time to move to our next speaker, Chen Lei from Meta. And today, Lei will be sharing insights on optimizing LLMs for hardware accelerators. This talk will explore how Meta is tackling this unique challenge of deploying large language models on NPUs, neural processing units, including extended context length. And the stage is yours, Chen Lei.
Great, thank you for the introduction. Let me try to see how to share screen. Okay. Oops. Okay, great. So, okay, great. Hi, everyone. My name is Chen, and I am a software engineer at Meta. So today I would like to talk about optimizing LLMs for hardware accelerators. So here's a quick overview for what we would like to cover today. First, we will start with a brief introduction, and then we will talk about optimization for LLM. Then we will talk about optimization for ANE, as well as the future models for hardware optimizations. So first, why do we want to optimize LLMs for hardware? So as we know, LLMs are usually huge models. It's usually at the scales of gigabyte. And then there's limited resource on edge devices. And that's the reason we want to fully leverage all the resource on the edge devices to unlock more potential. The hardware accelerators is known to be one of the most powerful units on edge devices. So let's see like some key potential we can do here. So first is efficiency. We want to reduce the energy consumption and then also improve the resource utilization such that we can run a powerful LLM without like draining the battery in just a few minutes. So second is the latency. We would like to enable real-time response and interactive applications. So we would like to have instant replies. That would be more ideal for users. Third is the cost reduction. We would like to minimize the operation expenses for the cloud. And then last is like the infrastructure cost and for inference on the cloud can be really expensive. And then edge deployment can unlock more use cases in the resource-constrained environments like smart speakers, autonomous vehicles, and then also the IoT devices. Running LLMs on hardware accelerator isn't like just plug and play. So usually we will have two major issues or like three major issues here. So first is memory. Accelerators like a single process in HTTP can only like probably like 4 GB at most because of the by design. And then like while some large models can easily exceed the memory, so this requires us to break the model such that we can run it on HTTP. And then secondly, accelerators can be very picky. Both HTTP and ANE only love static shape. And then HTTP mostly supports static quantization like FP16. And then ANE also has like very limited operator support. While like the prompt length for LLM are not fixed. Say, for example, if there are two prompts, like one is what is 1 + 1, and then the other one is tell me a joke. So they have different prompt length, meaning that they will have different shape. We spent quite a bit of time to figure out how to like work around the dynamic shape issues on hardware accelerators. Lastly, like there are limited data type support and then also operator support for hardware accelerators, and that can be quite challenging. So let me briefly introduce like what is the Qualcomm HTB. So it's a dedicated AI ML accelerators. It's inside the Qualcomm chip, and then the primary purpose is high performance energy efficient inference of neural networks. That means like we can use it to optimize to run AI models on devices with minimum power consumption, and it's a crucial part for mobile and edge computing. The diagrams on the right shows like what the that is like an example architecture for Qualcomm SoC. Yeah, so like in short, by leveraging HTB, we can make the on-device AI faster and also more power efficient. So while like Qualcomm Hexagon, while the HTB is like really powerful, it is also important to know some constraint when we are trying to leverage it. So first, like there's always like a limitation. I guess like maybe in the latest release, Qualcomm like maybe push a update to have it resolved on the software level. But generally, like for the hardware, it has a memory limitation. And then also it mostly only supports static shape for now. It supports some operators in some specific dimension for for dynamic shape, but like majority is static shape. That means like the dimension of the input data, like the prompt size, need to be fixed instead of like it cannot be dynamically changing. And that means like we need a dedicated solution for RM because like by nature, the prompt length is like always different. Static quantization is another issue. Like quantization is like a way to reduce model size, and then it can also improve the inference time. But then like on HTB, like this is generally applied before deployment. And then like the activation also like always need to be quantized. Lastly, like there's no in-place mutation. This will mostly affect KV cache, and then it will be usually will be more efficient if we can modify KV cache in place. So let's take a look at about like some optimization we do. So first is model sharding. Because of the memory constraint, like say for large models, if it's like AB models, then we need to shard models. The way we shard a model is like say for example for the AB model, there are 32 layers, and then we break it to 4 parts, and then we will loop and then process this chunk sequentially. And then this will allow us to run large AI models on device with limited memory. We did another optimization for the large language model on HTB, especially for the prompt processing. So we use this approach to work around the dynamic shape issues in LLMs while trying to optimize the prompt processing time. So this is usually what we call preview stage, and then it's actually HTTP's advantage because during preview stage it's compute bound, while like during the decoding stage it's memory bound. So in this approach, instead of like processing one token at a time during the initial prompt, we take n tokens blocks as the input. As we can see, there's like block 1, block 2, and block 3. And then we will store the KV cache. And then like during the processing, we will loop for like m times to process each block. And then in excuse me. And then in each iteration, the KV cache will be updated with the new outputs, and then we will build up the context. So this is this block by block processing for prompts while still leveraging the KV cache. It will allow us to run the initial input sequence in parallel, and then it will be more efficient. It is one of the key optimization to speed up the initial understanding of the prompt before generation. So meaning that we can have a much faster time to first token with this approach. And then we have 2 ways to excuse me. We have 2 ways to update the KV cache. KV cache updating is very important for both performance and memory management. So we apply some specific strategy to ensure this. Essentially, we currently have 2 approaches. One is the shift pointer, and then the other one we call it smart mask. So both are designed to manage the growing cache from the past information. And then they are slightly different in terms of like how they handle the memory updates. The goal is always is to maintain a continuous accessible history of the previous processed tokens. And then in this way, we can optimize for the speed and also minimize the memory overhead. So there will be lots of details, including like for the KV cache update. So I guess like I'm not going through the details, but other like if you're interested in dive deeper, like how these optimization are implemented, then feel free to check out our website, and then we include like comprehensive details about how this optimization is implemented. And Apple Neural Engine is another like custom design neural like processing unit, and then it's similar to other hardware companies. Like it's also tightly integrated to Apple's core silicon. Like you will find it in their A series chip, like iPhones and iPads. Also like in their M series chips, that's for Macs. Like other dedicated AI accelerators, the ANE is optimized for high performance and energy efficient machine learning inference. And then it's also crucial to enable like on-device machine learning tasks such that it can run smoothly and then will be also more power efficient. it's powerful, and then it's also important to know there's some like constraint while we are trying to leverage leverage ANE. So first, there's like limited operator supported, and then it's also a opaque part, meaning that like for developers, we have limited visibility to know like how it works internally, like how it's scheduled, or like all the low level performance, all the low level like characteristic, like we can't see that. So usually we will provide a model and then ANE will execute it, but like like the way we leverage ANE is through CoreML, and then that help us to deploy a model to ANE. So like with that being said, ANE is very powerful, but it also needs lots of work to figure out how to run LLMs on ANE. So in order to address those issues, the first thing we do is we have a dedicated model definition listed in this link that is also under XGTorch. We have a dedicated model definition, so that will be more ANE friendly. And then most operators will be running in ANE, so we can fully leverage the hardware. And then another key optimization we do is we are splitting the large linear layers to multiple smaller ones. That actually helps us a lot to improve the performance. So the way we split it is like we split a large linear to multiple smaller ones, and then we concat them together. Here's some, like we are actively experimenting with different settings, and then this is the setting we find that work quite well on Llama 1B on iPhone 15. So including like say what will be a sweet spot for the sequence length, and then what will be a good splitting size here, and then what will be a good max sequence length. So those are like some good settings we find works really well for Llama 1B on iPhone 15. And then we do another thing that is like we enhance our debugging tools such that it's much easier to find out the numerical discrepancy. So a huge model, like Llama is a huge model, like LM is a huge model, and then after optimizing with quantization and then like debugging numerical issue can be like really painful. So we provide a tool such that we can select the interested output such that we can find out like where this discrepancy comes from. And then, so this is really helpful. And then we can zoom into the specific layers or even like the individual operators. And then we can identify like where the numerical values might be like start drifting, making it much easier to fix issues. And now let's take a look about the future models. Based on the artificial analysis state of AI, the report there, we are seeing a strong movement towards the reasoning models. And then AI can understand and infer more like humans. There's also a big push for efficiency and then also MOEs, such that we build more powerful models without constantly increasing the size. I guess like MOE maybe can be kind of less related for edge spaces, but efficiency can be related there. And then agent is also becoming a significant area, like AI system that can independently plan and execute tasks is the trending here. Another major trend is the multimodality model. And the model can understand and generate content across different types of data, like text, image, audio, and then all at once. So these are the directions that like trend. That's like the trend for the next generation of AI. So first, we can see like based on the report, we can see the open weight models rapidly closing the performance gap with the proprietary models. So the graph shows like the black line is the proprietary models, like from OpenAI, and then like the blue ones shows the open weight model. So previously, like the proprietary model, like really lead the way, but we can see like the blue lines is catching up, especially recently. And then, yeah, this is a significant weight this is a huge win for the broader AI community. And then it also shows that like it also opens up like more opportunities to allow more customization, as well as like running the model locally. And then another trend is the reasoning model. So this bar chart shows that like the comparison between the reasoning models as well as the non-reasoning models. So the models with stronger reasoning capabilities can achieve a much higher overall scores across like all the evaluation benchmark. Say for example, the MLU and then also the Math 500. So let's take a closer look at the reasoning models and the non-reasoning models. So given the same prompt, non-reasoning model will directly have the output, while the reasoning model will have pretty much two parts. It has the thinking process as well as the final solutions. So this is the model output difference, and then we can see like based on the they have a big difference between the response time. So the reasoning model will have much longer response time, and then it will generate a lot more tokens. So how it will affect the edge? So it basically means we need to support more tokens. It will generate more tokens, so we need to have it like the generation needs to be more efficient. It also requires longer context length because it includes the thinking process. The fortunate part is that like those are actually also the goal for non-reasoning model, meaning that like our goal is aligned between like from infra perspective, the goal is quite aligned between reasoning model and non-reasoning models. And then another trend is that agents driven by the large language models. So unlike traditional AR that can only respond to some prompts, agent can like direct their process, use tools, and then also control and accomplish tasks. They can like have much higher level instructions, and then they can plan, execute, and also take actions, so they can achieve goals to end to end. The following, the application on the right, is like likely the dominant part this year based on the report, including like coding, deep research, computer usage, and customer support. So for us, our solution to deploy agents more effectively is Llama Stack. So Llama Stack is also open source for Meta, and then it standardized the core building blocks to simplify the AI application development. So more specifically, it provides a unified API for inference, such that it can cover it will cover inference, RAG, agents, tools, safety, evals, and also telemetry. It also have the plugin architecture such that it can support rich ecosystem for different APIs implementation, like local development as well as like cloud and mobile. It also include like the pre-packed verified distribution, such that like there's one-stop solution for developers to get started quickly and also reliably. In the meanwhile, like there are also different developer interfaces like CLI as well as SDKs for Python, TypeScript, iOS, and Android. It also have like a standalone application as examples for how to build production grade AI application with Llama Stack. For Llama Stack, the relationship between the Llama Stack and XTorch is that XTorch is like the backends for the Llama Stack. So for all the things that we supported, as like I stated earlier, Those are like the foundation for the Llama stack for inference. And yeah, they are like working together to build the whole system. Yeah, this is what I would like to talk about, and I am happy to take questions.
Yeah, thank you. Thank you very much, Shen, for that deep and practical look into the challenges and innovations in optimizing large language models. There are two questions from the audience. The first question is from Ainalem Arigawi. How is continuous learning supported in your optimization? Do you also have an option for federated learning of multiple devices?
Yeah, so we also have yes, we support further learning. Excuse me. So currently it's supported internally, and then we do have plans to have it open source. But like we do support further learnings across multiple devices. And then we also support on-device learning as well.
Okay. The second question by George Williams. Do you support multi-head attention like described in the DeepSeek paper?
We support multi-head attention, but I remember in the DeepSeek paper, it's a different one. It's the it's a different attention. We support both, I think. Yeah, I think DeepSeek is not multi-head attention though.
You said multi-head latent attention.
Yeah. Oh yeah, okay. Okay. Yeah, we support both. But yeah, let me double check so I can make sure my answer is accurate.
Okay. And maybe one last question from my side. You mentioned new tooling for debugging numerical issues in black box accelerator environments. Can you share how these tools have changed developer workflows or model reliability in practice?
Oh, sorry, like which slides are you referring to? Is it this
one?
The
debugging of numerical tools.
Oh, this one.
Yeah.
And then your question is like, how is it?
How does it like impact or change developer workflows and model reliability? I mean, in practice.
I see. I think it's mostly like, say, for example, the useful part of it is like, say, I have my model and then I try to run it in a specific hardware, and then during this development, when I actually can run a model on device, then like it's generating like a different result than the one we see in the cloud. And then that can be very hard to debug because like there can be tons of intermediate result inside of it. In the meanwhile, like for the hardware accelerator, it's opaque, meaning that it like with other solution, it's hard to see what's going on inside. So this approach like will help in terms of like it will help developers such that user can like say we can identify like those part that like we can identify like the really discrepancy part inside the model, and then we use that we can find out like which operator is like likely the issue that is causing the discrepancy. So this is a very powerful tool, mostly for developers.
Okay. Thank you, Chen. Thank you for closing out today's sessions with such technical deep dive. And with that, we wrap up an incredible first day of the GenAI Forum. We've heard from visionary leaders, from speakers, which we would like to thank each one by his name. Samir Jaber for setting the tone with the fireside chat, Ashutosh Kumar and Raymond Lu from Intel, Alberto Alvarez from NXP, and Nirban Bhattacharjee from Wipro, Pete Warden from Useful Sensors, Vinesh Sukumar from Qualcomm, and Chan Lei from Meta. And of course, all the attendees, your questions, insights, curiosity made today a true exchange of ideas. And now I'll hand it over to Danilo for any final thoughts to close out the day. Danilo, over to you.
Thanks, Ajar, for your wonderful moderation. Has been a great day. I think what I heard and what I learned is superb. You know, Peter, let me just say one point for each one. Samir, we are entering in the intelligence of everything, and human machine interaction and wearables, personalized. These are the key words I have in mind, and OpenVINO, available for everyone, to educate people, and with lots of use cases. NXP, superb. I mean, I know that I am from ST, but I mean, if when people do fantastic work,
no, that's why we're in a collaborative community, is everyone is contributing. And, whether it's Intel on kind of the open edge stuff that they're doing, or NXP, or Meta, everybody. Yeah. So that was one of my takeaways today, was like, what an amazing collection of resources, for people out there that are listening in the developer space, kind of figuring out, how can I experiment? How can I do things on my own? There was a ton here, and we're going to have a ton tomorrow too. So we're only halfway there.
Yeah. And everybody today, all the speakers, I was touched particularly by the advices of Pete Warden. I remember Pete always proactive in suggesting things and thought and approaches to the community. And today I had the confirmation once again. I think that was really wonderful from my side.
Awesome. Good.
Great.
Well,
looking forward to a great second day tomorrow.
Yes, I know. Everyone get ready, fresh coffee or whatever your thing is, and now you guys will break for dinner. I'll break for lunch. It'll be good.
Yeah.
All right. Sounds good. We'll see everybody tomorrow.
Bye.
Bye-bye.
Bye.